Hey, hey. Yep. All right, there you go. Dylan, you there, buddy?
Hello, hello. Oh,
So
I'm
you can
here.
hear us okay?
Are you there?
Yeah?
Yeah.
Yep. Okay. We're good.
Loud and
Let's move
clear.
on to Herbert. Bye.
Moving on to Herbert.
Me? No? No. It's not on? Can you? There it goes. Yeah, that sounds different. Hi, and welcome everybody to the Kernel Summit session. I'm Thorsten Lehmhus, or pronounce it as you like, I don't care much. And I'm talking about Linux kernel regression tracking efforts that I did in the last year and a few related things. And yeah, the talk will basically have three parts. The first one is just giving a quick overview of my work. The second are some best practice I took from, have drawn from that work. And the third is more of a discussion style where I want to discuss a few problem areas or everything you want to discuss. Note I have to leave right after the talk because I'm giving a talk at the Open Source Summit as well. A bit of this kind of scheduling conflict, but I'll hope to be back at lunch again. And I'll try to rush through the first two parts because all the main info is in the slides anyway. So my recent regression tracking efforts. Since about 1 year, I'm tracking regression reports for the Linux kernel again. I did it already in 2017 for a while. Back then, I did it completely manually in my spare time, which was really frustrating and a lot of work. So this time, I tried to automate things a little bit and wrote a bot, RegSpot it's called, that does some work for me, and I tried to not make it yet another bug tracker, but obviously it is. But it's designed to ideally create no additional work for Linux kernel developers because they have much on their plate already and don't want to deal with Bacilla or web interfaces. So yeah, that's why I really try to tailor it for that. Obviously, someone needs to tell this bot about regression reports. And ideally, the reporter can do that by including a paragraph like the one you see here at the bottom, where you specify the version when a regression was started to happen. If the regression was bisected, you can specify it as well. And you can do it for tell RegSpot about reports from other people as well, by including a small caret at the end. And Baxilla's and tickets and arbitrary links are supported by RegSpot now as well. So telling RegSpot about the report is actually all the manual overhead in the ideal case. But right now it's mostly me that's doing it and adding all the reports I find to the tracking. I look out for reports on the regression mailing list, on lore, and on bacillakernel.org. Once I edit the reports, the RegSpot looks out for replies to the reports, either on the mailing list or on Bacilla, but also looks for patches that are posted or committed that point to the tracked regression using the link tag. Yeah, and in the latter case, if a patch is committed with an appropriate link tag that points to the report, then the regression is likely resolved and RegSpot considered it done. And if you wonder, yes, that's actually what link tags are for. There was a bit of confusion with that, but Linus recently clarified it a few times. Just showing 3 mails from him here with the mails below it. If you're interested in details, what he said there, look at the slides later and follow the links to see what he actually said. He really said that those links are important to him because he wants to understand how the fix came into being and what the backstory was. It's actually why I improved the documentation a little bit to make sure the people really know how to use the link tag. So in submitting patches, clarified this part. It's more clear now than a year ago. And if you wonder, why don't we use a tag like buglink or something that's was never supported or never officially done in the Linux kernel? A few people did that. But Linus recently confirmed that he clarified that he doesn't want that and doesn't want to make people update random tags. So don't use backlinks, references, or things like that. Ideally, checkpatch would actually warn people about it and just tell them just use link instead. My Perl skills are actually not that good. Is anybody looking for something fun to do on an evening or two, maybe I would be glad if somebody could do that and take a look into this and submit a patch. Yeah, and the regressions, the RegSpot then tracks Actually, it compiles on the web page where it shows it. This is an overview, and each regression there's more details. And yeah, this web interface actually makes it pretty obvious for me if things stall before the fix was applied. And yeah, then I show up and prod things and make sure it gets running again and talk to developers. And if nothing works, I get Linus involved directly, which hopefully doesn't, which luckily it doesn't happen that often, but sometimes it's needed. Yeah, everybody can actually interact with Regspot using commands in a reply to the report. Here are a few commands, like you can tell, for example, when by fix by, which commit fixes a regression, or update when the regression started to happen, or give it a special title, or or point to other threads that Regspot should monitor. Yeah, if you want to know more about Regspot, check out the Getting Started guide on GitLab or the reference documentation. It explains all those things in more detail. Thing is, sadly, Regspot is still young and has many warts. One of the main reasons I'm not really a good programmer, but yeah, I think I'm doing something that a lot of people want, and it works, and it does a trick, yeah. And another reason is it also has some deficits because, yeah, it's just me mainly working on it, and regression tracking itself takes some time. One of the main ones, it's not really useful for subsystem maintainers. That's something on my to-do list, but that will take a while before I get to that, because there are quite a few other things that I need to take care of. First, here's a rough roadmap for Regspot. For example, one thing I hopefully sooner or later will work on is GitLab support, because graphics drivers, developers use a GitLab instance on freedesktop.org to track DRM bugs for the Linux kernel. So they escape me right now, but sooner or later I hopefully we'll get to that as well. In the end, Regspot makes regression tracking for me a whole lot easier already. It's still a lot of manual and tedious work, and that's why it's kind of still on a best effort basis. Yeah, but it does it's worth it. I think the efforts make a real difference, because quite a number of reports I've seen would have fallen through the cracks or only addressed much later. So thanks again for sponsoring the Regspot idea to the European Union. They sponsored me to bring this up for NGI Pointer. That project ended in March, and these days Meta is going up to sponsor my work to make sure I can continue, because it's considered important by the Linux kernel developers. That's basically the overview about Regspot. Quick best practices for handling regressions. Actually, my efforts made me write 2 texts about regressions and handling them that were added to the Linux kernel documentation. One is actually more for users. It's about reporting regressions and explaining what a regression is to ordinary users. And the other is mostly about handling regressions, and that's the one I'll focus on here, because there are a few things that are important for developers and maintainers. And it's not widely known, really, so I'll give it a few minutes. One of the important ones, so something that helps me a lot, is if you CC the regressions mailing list on regression reports, because then actually I become aware of the report and can add it to the tracking. Otherwise, I have to look everywhere to find the regressions, and that's obviously I always miss some regressions. Another thing, if you want to do, you could immediately get Regspot involved and making it track the regressions when you CC the mailing list. That's actually explained in the handling regressions document in the kernel. I don't want to get into the detail here. Let's just look it up there. When fixing a regression, that's also important. Yeah, just remember to use the link tag, because yeah, Linus wants them, Regspot relies on them. If you miss it, I have to catch up everything and check, hey, is this regression finally fixed, and walk myself through the commit log. And that's really manual work I'd like to avoid, because it's yeah, just waste of time, kind of. And so in other words, if you use reported by, you in most of the cases want to link to the report using a link tag. Same again, eagerly CheckPatch would suggest that, but isn't doing so. So if any volunteers are here, I'd be glad about that. Another thing is if you fix a regression that has also made its way into the stable tree, Remember to CC the stable tree. I talked with Sasha about this. He said the fixes tag is not enough. It will often do the direct, but the patch might be silently dropped if it doesn't apply for some reason. And Greg also recently replied on the mailing list that it's not enough. Yeah. Now we can get to the most important part, that it's fixed regressions in a reasonable amount of time. And obviously, what's reasonable depends on the individual regression. The handling regressions document actually has a section with a few rules of thumb there. And the short and rough version is often it's a week or two. For some regressions, more time is okay. But for many other, for some crucial regressions, just should take maybe 2 or 3 days ideally. And that's not till the fix is reviewed or something, but it's really till the fix is merged in mainline, because that's the point only when the fix gets to the user. So that's the important milestone. To achieve that, keep the following things in mind. Prioritize the work on regressions over all other Linux kernel work. That's nothing really new, because yeah, we're doing it for the users, as Linus once famously explained. It's a bit an older mail that's actually also quoted in the handling regressions document. He really said, without users, your program is not a program, it's a pointless piece of code that you might throw away. It's a bit over the top maybe, but in the end he's right. We're doing it for the users, and they need those fixes. Yeah, and that's also why regressions in the production releases often should have a higher priority and be fixed within a week. So higher than mainline RC kernels, because developers can help themselves. Ordinary users, on the other hand, often are not really possible, are not in position to help themselves. And yeah, that's again the user aspect. And to show that, here's a quick timeline how 3 distributions recently switched to the latest mainline series that was 5.19. OpenSUSE Tumbleweed, for example, just switched 11 days after the release, even before the first stable release came out, before 5.19.1. And Arch Linux just switched a few days later. And yeah, Fedora 2 weeks later, and between then 5.18 even got EOL. So those users actually have no way to go back to the old stable series once the distribution switched to the new series. That's why it's so important to get it fixed for them, and especially when the previous series becomes EOL or is EOL already, to make sure the regressions are fixed by then ideally. Otherwise, they run into trouble. As I said here, that happened even a week before Fedora switched to 5.19. And sure, some of you might say, why don't they go back to the latest long-term kernel? But that's often not an option either, because it's either not easily available or might lack required features. Yeah, sure, the users could stay on their previous working kernel, but as you know, most of you likely know, we fix security vulnerabilities every few days. So after a week or two, it's likely becoming a very bad idea. And that's why regressions in the latest production releases need to be fixed faster than those in mainline. So fix regressions in a reasonable amount of time. So the easiest way to do that is often simply reverting the culprit. It's simply easy and quick. Doesn't work always, but that's how it is. Especially it prevents more users and also developers running into known issues. And to give a bad example about this, there was recently a problem in the SCSI subsystem with some rework there that actually caused a suspend to break on many machines for 2 RC releases from 6.0. And that was actually the revert was actually posted 2 days after RC1 got out, but in the end it took 12 days to get it mainlined. And yeah, that shouldn't happen, because if you look closer at the timeline, there were seven people I know of that bisected the regression and had to deal with the pain that's a bisection and spend a lot of time for that. And those are only the ones I know. There are likely more people. So that could have been easily prevented if the patch would have been reverted much more quickly. Here are the references if anyone wants to go and look into the details. Another aspect is mainline the fixes quickly. The handling regressions document mentioned that, as I already mentioned earlier. So thing is, I'm regularly seeing fixes lingering on mailing lists or in developer trees for weeks, which is especially bad if the fix actually needs to be backported to stable to fixes in a production release, and that doesn't help anyone. I've asked a few maintainers, and they sometimes said, "Hey, I'm only sending my changes upstream every 2 or 3 weeks." And yeah, the thing is, if you have a regression fix among in your pile of patches that need to go to Linus, simply send them more often, and to Linus or your higher level maintainers, or even ask your higher level maintainer or Linus to pick it up directly. Linus really won't mind, I'm pretty sure, unless you do it every week, then it's likely something he won't like. Also, developers should sometimes, in my opinion, ignore the subsystem maintainer if he's missing an action and send patches directly to Linus. There's another regression that's actually an example from April. Something with the GPIO went wrong, and a lot of laptops actually didn't wake up from suspend. And actually, there was a patch that was backported to stable. And as Mario here complained, it was breaking people left and right because many distros picked the stable kernel up. And yeah, it was really a problem. Some people had to actually drain their battery to get their laptop working again. And that's also a regression that basically took 2 weeks to get fixed. It actually was merged for 5.18 RC2, and 2 days later already came into a stable kernel, and or 3 days later. And actually one day later, the regression was reported, and a little bit later on the day, the fix was even proposed. So by then, it could have been easily reverted. And I'm pretty sure Greg, in such a situation, if the fix is mainlined, would relatively quickly release a new stable kernel to get such a big problem out of the way. But in the end, it took 2 weeks again to get the fix mainlined, and also two weeks, then 3 days after that it was fixed and stable. And that's because the maintainer simply had missed the patch and the reports about the regression because it was in the spam folder. And that's, for example, one of the regressions where my involvement helped, because I told Mario at some point to directly submit the patch to Linus, and he actually a few hours later picked it up. And yeah, it worked out somehow, but it's not ideal how this worked. Yeah. And some maintainers, another aspect here is even let regression fixes wait till the next merge window. Sure, sometimes that will be necessarily if there's something big or something that's not that bad. But I see it quite often, especially with the Bluetooth and the Wi-Fi maintainers. And that's really quite bad for users if they're waiting for the fix or getting it backported to stable. And the thing is, these changes are often, in the end, get, in my opinion, less testing anyway. Because they're backported to stable shortly after RC1 is out. There are those big patches, the stable releases with thousands of patches, with hundreds of patches. But the thing is, even kernel developers sometimes fear testing RC1, so maybe those patches are not tested that much, and it might be really better to get them into mainline late in the cycle. So those were the 2 first parts of the series. What I'm in the time, but now I'm getting to the more discussion style. So problems I noticed or face. Quick explanation: I'm having a session on regressions at the Maintainer Summit tomorrow, and everything we discuss here, I'll try to summarize there. And if there's something you want me to bring up there, just let me know. either now or later in the day, and I'll try to do my best. And yeah, any questions, things to discuss, or remarks on what I outlined and explained so far? So on Regspot and its approach, maybe, or on the described usage of the link tags, or on the time frames when regressions need to be handled. Anyone? Anything?
So I guess I'll kick off the question with one. Most people generally think of regressions as things that broke in the last merge window, but from the perspective of many users, they may consider, well, I'm using the latest LTS and I found a bug, and the line between a regression and a bug report sometimes gets a little bit thin.
Yeah.
And obviously, if someone's reporting a bug for 4.9, that's very, very different than, say, 5.15. So where do you think the boundaries are of where you think Regbox is most ideally used?
I think if the regression actually was in 4.9 originally, then tracking it or happened before that, then yeah. I think it makes sense, and it might make sense to track regressions that were introduced in the 4.9 series. But if it's more a bug than a regression, then I don't add it to Regspot, because yeah, we all know there are some bugs in the old kernels that never will be fixed because the fix is too hard or too complex to get backported. Right. And yeah, I have a talk on bug reporting later today on the Open Source Summit, and there I explicitly mentioned that there are bugs that are not fixes that are not backported.
I guess mine's more of a PSA. I wanted to mention kernel CI, and I was hoping that maintainers would start using it more to detect regressions and maybe encourage their submitters, especially if they're fixing regressions, to land tests in kernel CI so that we can catch them in the future.
Ideally, those regressions kernel CI finds get fixed before the fix hits mainline. Yeah,
that's the ideal, right?
Yeah.
So more of that.
Yeah, I was going to sort of ask a obliquely related question. It's like we're looking at doing pre-merge CI with the graphics stack, but probably using GitLab because we have enough infrastructure already. But do you think we've got enough tracking at your level that you would notice, like if pre-merge CI became a thing, you think you would be able to see like a decrease in regressions at that level? Or so how to encourage other subsystems to get on the pre-merge CI path, and how to get, do you think we would notice a dip in our numbers if we did this, or some way to prove that it's worthwhile, because it's a lot of effort?
Yeah, right now I'm kind of staying out of the way with the kernel CI people and all the CI people, because I'm focusing more on the user's point of view to make sure that regressions that are reported are actually getting fixed. I think once a regression hit mainline, or even next maybe, then it might be okay to track it with Regspot to make sure it's really getting fixed before it hits users ideally. And but obviously it needs to be a regression that users actually face, because some of the CI systems find theoretical issues, and neither the developers nor I want to waste money on tracking down things that don't happen in the wild.
So when it comes down to stable releases in particular, you have an issue that sometimes something comes in as a regression, and you'd think that the easiest thing to do is just to revert that patch. But really what that patch is a bug fix for a whole bunch of users, and it breaks a whole bunch of different users. And so you end up with this, or do I revert this now, or do I get it fixed now? And if we can get those things fixed quicker and pushed in, those are the fixes that a lot of times will end up sitting in oh yeah, we're waiting for next merge window, or they'll sit in a tree. I've seen a lot of stuff in the DRM stuff just kind of sit there and never make it to mainline for weeks. And
yeah, that's why I mentioned that quickly mention getting the fixes mainlined is important. And regarding stable, I showed this picture. One of the things I'm going to propose tomorrow is that we revert fixes more quickly. That's something I want to ask Linus. But also allow patches or things that are causing regressions to get reapplied, maybe like 1 or 2 weeks, or maybe even 3, outside of the merge window, to make sure developers don't fear regressions that much, because that's why many of them try to find a fix for the problem, and instead of just reverting the patch and fixing it and then getting both in. And that's also, I guess, what will help Greg here. If there's a revert, you can simply backport the revert, and if it's tagged properly, and when the fix that actually caused the regression in the first, the patch that actually caused the regression comes back, he can backport it as well if it's just properly tagged, and so it's easy for him as well.
Right.
And that could speed things up, I think, quite a lot.
Yeah, we end up in place. I mean, in Fedora, I've a few times said, all right, well, I'm going to revert this patch for stable until it gets added back into stable or there's a fix. But a couple of times you get that and you're like, all right, well, I'm going to do that revert. And then you have this whole group of users saying, no, that fixed my thing.
Okay.
And then you end up in this weird.
No, yeah, we should leave the old bug.
Right. Yeah,
The old bug.
that's fair. But I mean, the old bug was also a regression. So at some point it's.
Well,
you know.
Sorry, so I said leave the old bug, and that's the idea. And sometimes I leave bugs in stable on purpose because I want to force the maintainer to actually get it fixed in Linus's tree.
Right.
So I won't revert it in stable. A little pressure point.
Yeah.
Sometimes that's not good. It's a fine line to play there.
It depends on the bug. And so that's sometimes it depends on the bug. Sometimes I will do
Totally.
the
Like
revert in
the
Fedora.
GPIO laptop, if I had known about that at the time, I would have quickly gotten it in stable.
Yeah. Sometimes I'll pull it out of Fedora just until there is a fix in stable, and then I'll put it back in.
Yeah, but let me know too.
Yeah. Okay.
You don't tell me.
Okay.
That was I want to know that was a bug.
Yeah. Okay.
So I know you're much too polite to do this, but I'm going to ask anyway. Are there subsystems that are doing really badly in terms of regressions that they're adding? And then I'll make it easier a little bit and say, are there subsystems that are really tracking this well that we want to hold up and say, look, everybody do it like this. These are the best practices. And you over there, maybe we'll make Greg say the bad words. You over there, like, start doing this now.
Maybe let Greg, yeah?
There are some subsystems doing really well. Some file systems, I will call out ButterFS as actually doing a really good job. They do a good job. I will call out Bluetooth as being a horrible pile of crap.
Actually, Bluetooth was on my mind as well.
Bluetooth
Wireless
is-
sometimes.
But we called them out publicly to get the company that was funding the developers to actually give them the time to do the work. They weren't being allowed to do the work. And that's not the developer's fault, that's the management's fault. They're getting better, but Bluetooth still has a ways to go. The regressions in Bluetooth, I hit it on my own systems every RC1.
Yeah, and for subsystems, I only.
There's a couple of some other ones are
Yeah.
good. MM is good. There's a couple other ones.
Yeah.
KVM is really good.
I got the impression that the subsystems that are quite distant from Linux are the worst, because they don't get yelled at by Linux. And that's, for example, the case with Bluetooth, because they are going to the network tree. And
Yeah, Bluetooth
So maybe
has
we
like
should
3
talk to-
steps removed. Wi-Fi is getting a little bit better, but then the network developers are very responsive, and network is also very good. But it's just getting it to them
yeah,
is harder, and some of their
They-
CI. And
the network maintainers for their stuff, they are often quite.
they're very good. Yeah, it's fast.
Yeah.
There's a lot of good.
I guess, like we mentioned CI before, it goes hand in hand with regressions. I would hope that the people with the most regressions are the most interested in adding more CI so that we can get out of this, cycle of sadness, right?
Oh, but Bluetooth is really hard for CI because most of these are broken devices and broken boards and new hardware, and a new feature broke a different board. And I feel for Bluetooth. It's a tough problem.
Hi. So what happens when you have some hardware that has some features? You enable them in the kernel. User space is using those features, and then later on you discover that those features can corrupt the system in general because they can heat it up too much, or they produce bad data. So you need to disable those features. User space will be broken because they rely on these features. That's a regression. That's not a regression. What's the guidance here?
So the document I mentioned for the users about reporting regressions, that actually explains the line when a regression starts. For example, if you enable an incompatible feature, then it's obviously not a regression because you have to make old config. And when it comes to user interface, and it sometimes gets tricky because you add something and then something breaks and you revert, or you have reverting would cause regressions for others, and then you have to look into the details, what is the least evil in the particular case. But I think I didn't really answer the.
So just put something particular. Let's say you have a camera that has
what?
A camera.
Yeah.
That has two resolutions, a big and a small, and you realize later in your development process that the big resolution breaks the hardware. So you need to disable it. The problem is there's user space applications that depends on this big resolution, and that suddenly is gone.
Yeah. Then you have to sometimes, I'd say, you have to find some way
It's tricky. It's a
fix
case by
it
case
without
basis.
breaking.
I mean, you can also say, hey, we didn't have this working last kernel. Sorry, it's still not working now. You're
Yeah.
going to burn up your hardware. It's a case by case basis, but that's actually really rare. As far as what I've seen, that's a very odd thing. Normally, you can always say, this feature is being ripped out. Or we mark some features as broken because they weren't quite ready. We're infamous for doing that. Just talk to the user. I mean, people are reasonable.
Yeah. But it's not rare. It's
Well,
these kind of things, especially with hardware that implements standards, is not rare.
so then let me point out, I never see those fixes landing in stable because Video for Linux, I never get patches. That's a subsystem that I know never ends up in stable because nobody ever backports anything. So I'm not seeing anything breaking in stable from that. And maybe in Linus's tree, but then you have the whole RC series to work that out, right? Very rare do I see a media patch. Oh, sound. Sound is a very good subsystem for stable too. They're really good at that.
Okay, I have a few more things on my list. I'd actually like to move on a little at least. I'm sure I won't go through all of it. One thing I saw during my regression tracking efforts is that that Bugzilla kernel.org is kind of a problem. I'm kind of watching out for reports there currently, but it's kind of a mess sometimes, and I think it's really bad for us. And that's something I want to discuss here, what to do about it, because there are really some good regressions report there that apparently no developer actually looked at. I actually looked closer for 2 weeks some time ago and posted it to the summary to the Linux kernel mailing list. That was a few months ago. And from most of the regressions I found, never got a reply from a developer within a week. And there were really good reports among that. Thing is with Bugzilla.kernel.org, I don't know if you know, it's the server itself is well maintained, but products and components and default assignees and the things are all heavily outdated because there's nobody really taking care of it. And the thing is, the server was never really became official place to report bugs, at least for most of the kernel. About 20 entries in the maintenance file actually tell users to file bugs there. And a few more developers take a look there. But in the end, many reports, either regressions or bugs, never get a reply from the developer. And yeah, Konstantin clarified a few things, and that's not his job as his admin team to maintain the list of components of the thing. And it's simply that nobody does that, and I don't want to blame any developer for not looking there because most of subsystem never committed to look there. But on the other hand, it's bad for our reputation and scares testers away if all those reports get ignored. Even some kernel developers sometimes don't know about the semi-official state or more unofficial state of the bug tracker and file bugs there and then wonder why they get ignored. Currently, I look out for a regressions layer, but it's quite time-consuming task, and I ignore everything that's not a regressions because there's only so much hour in a day, and that's why I think isn't it long overdue that we do something about Bugzilla kernel.org somehow? I don't know what. I'm pretty sure quite a few developers will actually be happy about some change as well. So quick show of hands. Who is awake? Yeah. So who thinks Bugzilla.kernel.org is fine as it is right now? Does any hand go up? No. Yeah?
I think it's fine.
Fine for
Yeah, that's because your
Right.
subsystem uses it.
So
They-
our
they-
subsystem uses it, and we track them. We track Bugzilla, and we have for decades. The problem is somebody files a bug in our subsystem, and we go, which is power management and ACPI, and we go, oh, this is a Wi-Fi bug. We put it under Wi-Fi, and then it's the black hole. The other categories
Exactly.
are dead.
That's you doing it wrong, though, right? Because you know that the Wi-Fi developers don't use Bugzilla. So
Yeah.
Some do, some don't.
why are you consigning this bug to somewhere that you know it will never be addressed? You should be forwarding it to. the
Okay, then
Wi-Fi
delete the
developers.
category for Wi-Fi.
Yes, exactly,
Yeah,
exactly.
Yeah, that would actually be something. Yeah.
And I think in the header, like in the HTML for bugzilla.kernel.org, it needs to say if there is no component for your bug, that component doesn't use Bugzilla, you need to report it to their mailing list.
Yeah, I guess but in the end, then we strip down Bugzilla to ACPI, PM, and PCI. Those are the three main subsystems that are using it. Is
ext4. Yeah,
okay.
and ext4, it goes to our mailing list, right? So, and I like it going to our mailing list because very often developers reply to the message when they see it on the mailing list, and it auto puts the comment in Bugzilla. And sometimes there are long-running bugs where Bugzilla is one of the better places to find things, at least pre-lore.
Yeah.
Right now that we have lore, maybe it's not as important. But yeah, we use it at ext4, and it helps because anything to the component goes to the mailing list, not to an individual developer.
That works for some subsystems, but other subsystems do that, and that's a black hole as well. So it's kind of a mess. But I mean, yeah, we could keep it running for those subsystems that are really interested in it. I guess it should be easier. Just somebody, I guess I'm volunteering by actually bringing this up, to clean up the list of components and products. And what do people think? Or should we close it completely? What? Ben?
Okay.
Well,
If you close it completely, we'd have to reopen it immediately. So no, that's completely unacceptable.
yeah. Okay. Yeah. But is it really worse for the few subsystems that are using it to?
Do you want power management to work on your laptop?
I mean, no. I didn't want to apply that. Sorry, but I mean the DRM guys, for example, went to GitLab. Yeah, they have their own instance. Some people use GitHub. Would that be an option for you? I mean, I don't want to shut it down tomorrow. It will be discussed. I just wanted to get a feeling what people want, because I don't like this.
Yeah,
mess,
I
and
have to
guess
say
most
we
people
have
don't.
tracked thousands of bugs in it, and it's not Bugzilla or the server or even the administration. It's the human use of the tool.
Yeah,
You're
yeah,
either
definitely.
using it if you're not. If somebody's not using it, it's not going to work. If you're using it, it can work.
Oh.
I think it basically started when Linus said, "Oh, I only look at email, and Bugzilla's uncool." And then all the fanboys said, "Oh, I want to be like Linus," and that just sort of set the culture.
Yeah, no, we created Bugzilla when it was like every project had to have a bug tracking system, and 3/4 of us said, we hate this, we just stick to email. I mean, you were there. It was a mix at the time, but some subsystems tried it and worked. I mean, I'll admit USB, it's a black hole, but we do forward it to our mailing list, and it's still a black hole because everything marked comes as a USB bug. But it's just I mean, I'm for keeping it alive for the 3 subsystems if you provide some help to actually maintain the server. I mean, it's a dead server. That's the big problem too. We have nobody doing the work. So maybe Intel can sponsor some sysadmin work. I mean, that's the other side of this. Nobody's actually sponsoring this to get it done.
Well, that should be easy.
Okay, that'd be good. But I mean, maybe just we cut it out and leave it for the 3, 4 subsystems that matter, and that's only drop-down boxes. And
Yeah,
go
so
from there.
unfortunately, Constantine isn't here.
Yeah.
My understanding from talking to him a while back is the email bridge between the mailing lists and Bugzilla, which as far as I'm concerned is the one thing that makes it usable, is a custom hack that is degrading. It makes it difficult to upgrade to new versions of Bugzilla because that's not an upstream feature of Bugzilla. It's something that somebody hacked a long time ago.
And Bugzilla development kind of stalled also in general upstream.
Yeah.
I think so. In the long term, we might need to look for something different anyway.
Right. Yep.
So what should I tell? What should I tell tomorrow? That some subsystems still want to use it, but
Yeah, some want it, some don't.
yeah.
Go from there, figure it out.
Yeah, I mean, there are other email-based bug tracking systems. I use Debian bug tracking system for all the Debian bugs. It works well for me, but like, you know, I don't think we should talk about technology as much as let the technologists figure out what meets our requirements if we can actually give them a coherent set of requirements. Right? Let Constantine figure out what's the best way to help us, right? Just, we need to tell Constantine what we want.
Anything, or I still have?
Do the first bullet.
Huh?
Do the first bullet.
Yeah.
Yeah.
Len, would you, if you're so relying on it, would you help with the first bullet, or your ACP npm? Because somebody needs to keep an eye on things, or at least clean things up.
Well, we have a couple categories of things, right? We've got stuff
I
filed
mean-
against us.
I mean, for those subsystems that don't use it, that's actually a black hole, because that's annoying for everybody.
Well, I don't really know how to pull off the Band-Aid to, you know, say last week we categorized something in another component and it's a black hole. What do you do with that?
Yeah.
There's got to be a house cleaning. There's got to be a flag day.
Somebody has to take a look at it and monitor it if things working, and just scratch the components and products that are not working to make sure people don't report bugs that are never forwarded to anyone. Yeah.
You can kill the product or category without subsystem without killing the history, right?
I'd say so. Yeah.
I'm not sure you can. I've got a small bit of experience with Red Hat's Bugzilla, and the maintainer is a friend of mine. And he says, like, the database is where all that stuff is, and if you remove things from the database, you can't get the history back. You could maybe archive the whole of the things, or try to hide
Can't
them.
you hide it somehow?
I don't know.
Not file, not
I don't know if there's a
books?
decent way, because then how does the searching going to work, and how do people find the old bugs? And
Okay.
so the schema is it's very, it's going to be intricate. I don't think it's as easy as just going in and saying we don't use these components anymore.
Yeah.
Oh.
Just rename the component to obsolete space name.
Well, obsolete it.
Rename the component to obsolete space name,
That should work. Yeah.
and do that for every single component. And then the components that want to be in, they remove the obsolete part.
So I don't think we want to call it like obsolete Bluetooth, right? You know, there's nothing to replace. So I
Main
mean,
only.
we have two different problems here. The first one is we need to have Bugzilla reflect how people actually want to maintain their projects. And maybe it sounds like the best answer there is some kind of auto response to every Bugzilla in a area that isn't well tracked in Bugzilla, of like, hey, we see you filed a bug. It's probably better to go to this mailing list instead. And then have communities that actually want to use it opt in. The second problem is, how do we make Constantine's life easier? And we should just ask him, like, we can't decide how to make something maintainable. He needs to make some suggestions, and then, you know, we can get together on whether or not those suggestions work for us. And I know we're out of time.
Yeah, we're out of time.
Yes, thank you.
Okay,
Thank you.
great. Oh, you have the mic already?
Yeah, I've got one.
You know how to switch?
Yeah,
Oh, yeah.
right. So. So, is it time? Okay. Then let me start. Welcome everybody. I'm Philip Rudo. I'm software engineer for Red Hat, and I'm working on the kexec and kdump team. And yeah, while working on kdump, I sometimes, or I find it pretty frustrating because some tools are pretty old and have, in my opinion, a fundamental flaw in the design. But, well, the problem is fixing this design isn't that simple. So I want to start a discussion here on how we could improve the design. And no problem. And yeah, having that said, this talk will be pretty high level and it is meant for discussion. So if you have any comments, or think that I got anything wrong, just shout out and we go from there. And yeah, so what's it all about? You probably all know kdump and most likely have used it in some way or the other. So just a quick recap for those who didn't. Kdump is a mechanism for dump debugging or post-mortem debugging. So it's including, or it is based on kexec, but it also has a big user space part in it. And it's essential for what I call here service providers. So distros, hardware vendors. So everybody you can pay money so they fix your problem. Within this mechanism, there are two tools which are quite essential and supported by, I think, every major distro. It's on one hand make dump file, which usually runs in the init.rd and is used to read proc VM core and then filter and compress the dump so you don't waste so much space on your disk. And the second tool is crash, which then reads the dump, well, does all the analysis, presents you the data in a human readable form. So one is a dump creator and one is a dump analyzer. Those two tools, as said, are pretty well established, are around for many, many years and supported by major distros. So what's now the problem with those tools? And well, I think the problem is, or has three parts. One, they need to parse the unstable KABI to work because, well, when you need to translate an address, you need to know where the VMA areas are. When you want to display the modules, you need to know how those modules are stored in memory, etc. And per definition, that's unstable and for a good reason. Second part of the problem is, well, both tools are pretty old. I'm not 100% sure when they all got about, but for crash, I'll show you on the next slide. It's before I started using Linux, definitely. And the last part is, well, both tools try to be backward compatible. So you can debug any kernel with the latest tool. But that means, of course, when you have to parse the unstable KABI, the tools need to know all parts of this unstable KABI, which means all the history of the kernel will pile up in those tools. And because they are old, or already quite a lot of history has piled up. And that is a fundamental problem, which isn't that simple to fix. So how bad is it? Here from Crash, there's this very great quote: one size fits all. The utility can be run on any Linux kernel version dating back to 2.2.5-15. Well, -15
hints, it was some distro kernel, so not upstream, but upstream 2.2.5 was released on March 29th, 1999. Back then I was 11 and in high school, and yeah, definitely hasn't used Linux before. And now when I'm working on this tool, I'm supposed to know all the history back to this version, which doesn't work out. Make-dump file is a little bit better. There's the oldest version is I think 2.6.15, but still not very recent. And of course, this history causes bugs because you never really, you don't have all the history in mind, and you don't have a way to test all the kernels with your test or with a change you want to provide upstream. One bug that I want to just point out here was reported last summer. It's basically on memory management, so how the mem section is traversed in sparse mem extreme, and originally, or the change that introduced the underlying problem was included in September 2017, and it's basically just a type change from an array to pointer to an array. While this was, first fixed in the kernel as well, or fixed in quotes, because this so-called fix caused more problems, in my opinion, than it solved. Then there was also a fix in make-dump file to handle this change. But then as time progresses, there was a lot of change in the memory management, especially in the memory hot plug area. And then in the end, there was also a kernel bug. And this kernel bug needed treatment in make-dump file as well. The problem here is that, the bug was, of course, fixed in the kernel, including stable, but as the bug also made it into the distros, make-dump file needed a workaround for this bug. And it was about, 2 years after the original change was introduced. This workaround then introduced a bug in make-dump file that caused dump corruption on S390, which is, bad. Luckily, it's a rather rare code path that was hit here, so it took another 1.5 years to this bug to be reported. So we are just looking at about 3-4 years of history here, but already this was extremely hard to fix because, as said, memory management isn't that trivial to understand, and in addition to that, memory management or the memory hot plug reworks just made the code look completely different. When you're now, from an outsider, try to understand the code plus all the changes made in the last years, it's basically impossible. So, but that's, of course, you need to know because you don't want to introduce another fix that just breaks some other older kernel. In the end, it took 6 engineers and 10 months to get up with a fix for this bug. And in my opinion, that's just a waste of time and resources and needs to be fixed somehow. And personally, I also say it's a constant cause of frustration because you spend a lot of time in the Git log, but not the code. And that's, you can spend your time better than that. So, but there's another aspect because, as always, you also have to look at security. You're having here C code, and you have basically a big binary file you're parsing. And this file has a pretty complex format. High complexity leads to bugs, leads to security vulnerabilities. And that usually shouldn't be a problem for you as a developer, but when you're in customer service, you have to work with dumps provided by the customer. And can you trust this customer? Because there's no way for you to verify if this dump has been manipulated or not. That means
the code has to be able to handle all those unexpected input. And the more complex your code is, the more difficult it is to really handle those inputs. And the problem is also when you have complex code or a very complex format, you cannot really use a fuzzer because you need to give the fuzzer hints on how your data is structured, but you cannot really do that when you have multiple versions of it. So this is also, I think, one of the aspects which is quite often missing, because when you look at most of the code in the debuggers, so not only make dumping and crash, but also other examples, they most of the time expect the data they receive to be the data the kernel has, but they don't expect the data to be somehow different. And you always see that also when there's some memory corruption hitting the wrong space. So what do we need to do? Of course, well, we need to find ways to reduce the complexity of those tools and to find a way how not to accumulate more and more history. What options do we have? Well, when you go back, we had 3 parts of the problem. One was the unstable KABI. So most obvious, just switch to a stable KABI, which of course for the debugger is perfect. You only have to support one version that never changes, and all the problems are, pushed to the kernel developers and don't bother the debugger. But I think that has been discussed, and many people found it not to be good, and so this won't happen. Next option was, or next part of the problem was, those tools are pretty old, so nobody uses 2.2.5 anymore. Why not just switch to a newer, more recent version of the kernel to support as minimal version? So yeah, or as others call it, just clean up the fucking code. But it sounds simple in the first place, but where do you do the cut? When I ask you people here in the audience, it's probably, or I get a completely different answer on what is an old kernel compared to what people use in the field. Because when we, for example, look at Red Hat, most of the people are still on RHEL 7. So it's a 3.11 kernel. Shall we, respect them and still support a 3.11 kernel? But then we have a lot of work for barely any benefit. And if we go to something much more recent, you suddenly have problems like, okay, distros need to know which tool version you can use with which kernel version. You need to discuss things like critical bug fixes. You need a stable process, etc., etc. So it sounds pretty simple and straightforward, but actually it's not that simple when you think about it. So let's go to the third option. We had that's backward compatibility. Why not just break this? So it's basically a mixture of option 1 and option 2. Just, clean up all the old stuff except for the very, very new one, or the Linux master. Because the big advantage here now is you're back to only support one version of KABI. You have a direct mapping between kernel code and tools code. And you can, and when there's some disagreement, the kernel is right. So no history, nothing you have to worry about. Of course, this still leaves all the problems I've just discussed for the distro, because, well, they now have to learn how to handle different tools versions with different features, etc., etc. But what's the big advantage is when we really only support the latest and greatest kernel version, why not just move all the tools into the kernel tree and maintain them in the tools directory there? Because once we did that, we have many problems already solved. The distros know how to backport kernel patches. We do have a stable process, etc., etc. So all the experience and all the tooling and everything that has been done for the kernel, we can simply reuse in those tools. So, well, let's take a better look at this option, because at least for me, that's the most promising of those three. So, what pros do we have? Well, as already said, we have a direct mapping between kernel code and tools code. So there's no more history, nothing. So whole complexity is reduced to the same complexity the kernel already has. And this, of course, makes it a lot easier for all the testing and automation, because experiences, for example, that when you have a bug introduced upstream, so or a regression introduced by some kernel change upstream in one of those tools, the same bug will be introduced or reintroduced once this kernel change is backported in the distro, which is quite annoying, because this then holds up all the people working on the distro kernel until there's a fix in those tools. And this can be a lot, this can be avoided by simply using a fixes tag, like suggested down there. And other tools like you can use is like an KABI checker. So when you only have one version of the KABI to support, you can extract like all the symbols you're relying on and check, okay, have they changed? And with that, you get an early heads up within the development process, maybe even within Linux Next, to get a heads up, hey, something changed, go look at it. This isn't impossible at the moment, and with that, it takes sometimes extremely long till those bugs are found, or those regressions. And with that, of course, bugs propagate into the distros, etc., etc. And yeah, as already said, we have well-established processes and tools as well upstream and downstream. So we don't have to reinvent the wheel for the same problems the kernel already has. Yeah. Mike?
Oh, yes. Okay. So there is a question in the chat, more like a comment. Maybe you can address that. The comment is, I think trying to make crash secure would be a waste of time. If you're worried about dump with an exploit, run it isolated in a VM or something. So
could you repeat it again?
Yes. So the question is that, can you not run, if you received a dump, can you not run it in a VM? Why are you concerned about the security aspect of the dump?
Can you maybe remove your mask? It's
okay, sorry.
Sorry.
I'm sorry. So the question is, I think trying to make crash secure would be waste of time. If you're worried about dump with an exploit, run it isolated in a VM. Would that solve your problem, or would you have to go through the complexity of making crash secure? I guess that's the question.
Well, of course, you can isolate the server where you're debugging, but that, in my opinion, just adds another layer of security, but doesn't really solve the problem. Because, and okay, what I maybe mentioned on the side, it's not only those direct manipulations for an attacker, but it's also memory corruption those tools have to handle. So they, in theory, should always not trust the dump data, not only because it might be bad or might be manipulated by some attacker, but also just pure memory corruption. So because of that, I don't think just moving the tools into a VM will solve the problem. In that, I think you need to have the tools to be able to handle any sort of input, and at least exit gracefully with hopefully some meaningful error message instead of just crashing. And with that, I don't think just moving to a VM will solve all the problems.
Yeah, I have a question. I think for K-dump file, it's very okay to move it into the kernel tree because you dump with the current kernel version. However, for crash, a lot of time the crash dump are analyzed in a different machine, which may run a different version of the kernel. So that means that for those machine that analyze dump, you need to have multiple versions of crash installed and intelligently pick the right one to use for analyzing the dump.
Yes, you would. In this model, you would need to have the correct kernel version, crash version installed on those speaker machines.
So, if I remember correctly, crash, the source code was embedding the whole GDB source code. So how would that work with putting all that in the kernel?
It won't, because next slide, that's why I'm representing here, it will be a multi-year project and we have to redesign crash. So for me, crash and make dump file isn't in the state currently to be moved to the kernel tree. For make dump file, I've got the hope that it can be cleaned up to be included, but for crash, we need to find a way to not rely on out-of-tree GDB patch. And currently, for me, the best bet is to rely on the Python API GDB provides, but that would mean to port most of the crash code to Python.
One thing is like, we already have BTF for annotating the kernel structures. Why don't we just extend it to provide all the information that crash needs? And then we don't need to have multiple versions. One single crash can support multiple kernel.
Sorry, I didn't get it.
So today, with BTF, we can annotate the kernel. And that's part of that specific kernel. So we can extend BTF to have all the annotations that crash needs. And then a single crash binary is going to be able to analyze any single kernel. And we don't need to change the API.
Well, yeah, but crash also has something like the struct command. So a user can simply say struct this, any arbitrary structure in the kernel, and crash will read from the dwarf information or the structure information out of it. So would need of all structures in the kernel a BTF format or a part in a BTF format. And personally, I think that would be too much. It's there. It's from all. Okay. Mike.
You can use p-hole something, whatever, enumerations, structs, or whatever, and it will show it almost instantly. You can ask for expanding it all, getting offsets, whatever. All the data structures for the kernel and for modules are there. Information for types for per CPU variables are there. There is a patch to add the types for all global variables in BTF. People are considering this. Alexei think that this will increase BTF too much, which is about almost 2 megabytes more.
Yep.
And he's suggesting that we put this into an extra module, separate, like a kernel module.
Yeah.
Then when you need that with something like this, or something like a debugger, or whatever, then you load that thing. And you use it. BPF trace would use, whatever. But nowadays, BTF is all the types in the kernel are always available. It's in kernel memory at all times.
But that's only the debug information stored in there. So not the information on how, for example, struct modules are ordered in memory, or where you have the entry point to traverse all the list with all the modules currently loaded.
I mean, you can. I mean, for that you have kernel data structures already. I'm talking about only struct layout, where they are. Oh, here I have a memory. I have a variable. I want to dump it.
Yeah.
It's all there. You have even printf like that. You have print k that you say something like, oh, use the BTF information and print it.
Yeah.
It's there. It's there already.
Okay.
So along with that, there are debuggers that actually already do support BTF for the type info. Dragon is one example that is very similar to Crash, and it can already, well, it cannot in a released version do it, but there are already implementations out there for using BTF. And they also, for your concern about finding data structures, finding globals, things like that, you can use KLSIMs. The kernel's crash dump in 6.0 is getting all the information necessary to find the KLSIMs table, and then from there, you not only have BTF, but you have a symbol table. So a lot of the things you need to do to read through a kernel are available.
Okay, yeah, but that only solves the part of the problem in finding those symbols and getting the debug information, but not on how they are stored in memory and how they are ordered. And this is the KABI
Where
problem,
page
I
tables, things like that, I understand there's more.
Yeah.
But let's extend BTF to have that information that you need. But I think that discussion is orthogonal to where the tool should be. I agree that the tool should be in the kernel tree. I think that makes perfectly sense. But yeah, I will. There's a lot of use cases where you have a lot of kernels and you don't want to have a crash that's 6.5.1.22.3 because it's not that you're going to need one per kernel. You're going to need one per specific version, a specific patch set per vendor. So, and that I don't think that can scale.
Yeah, that's one of the problems I see as well. But at least in my opinion, when you, for example, take an approach like perf and you have a separate package for your debugging tools and you just install them and maybe have a wrapper script provided by the distro, you can handle this, in my opinion. So it's not really, yeah, when you really have to type the whole path, the whole version and everything, it's not user-friendly, but it can be made more user-friendly, in my opinion.
It's because we need to figure out who is going to consume this. So in one hand, you have the users, which this is great for them, but most of the time, who needs this is corporation when you need to trace a lot of data. So in Chrome OS, we are also considering using enabling KDump for our notebooks, and it's a completely different use case because we don't have that much memory as a server, so we cannot just place 256 megabytes, save 256 megabytes for having our kernel crash. So instead of that, what we are looking is a tiny kernel that the only thing it's doing is fetching the dump, put it in memory, and rebooting the machine. And when we are doing that, we have already identified a couple of things that could be in the kernel to make it stable, as you are saying. That will be great. So maybe we can have that discussion later.
Yeah.
So I had one quick comment here about just sort of a practicality issue, which is realistically speaking, most of the distros that are, for example, looking to deploy 5.15 LTS into a product will probably be doing so in the next quarter or two. And so we may start finding problems with parsing the 5.15 LTS KABI when the 6.0 LTS is already out. And so it may end up being that you will end up having to direct apply a lot of fixes for the crash examination tool for 5.15 a year or two after, right? And there'll be fixes that have to go straight to the stable kernel because the 6.0 kernel is for the 6.0 KABI, and the bugs that are being discovered only show up once the distro customers are using the distro kernel, which is 5.15 based, which might be a good year after 5.15 has been released. That's not an insurmountable problem, but it's a little bit different than say perf, because perf tends to be used much more by developers, so you find the bugs early. Whereas with crash, I predict you will find a lot of the bugs a year or so after the LTS kernel was released. So something to think about.
Yeah, no, that's a fair point. But again, why I was proposing this here now is it better to have this delay, or is it better to pile up more and more history and have, in the end, an unmaintainable project? So what's the bitter pill you want to swallow?
So one comment I want to make is you're absolutely right. Rewriting Crash is a huge multi-year project. You mentioned Dragon on a later slide. I mean, it's been multiple years now. I think at least in the meta infrastructure, we never run Crash anymore.
Yeah.
We go through a lot of dumps. Dragon is run automatically on every dump in the fleet. Feature-wise, it far surpasses what Crash can do. So my suggestion would be to sit down with Omar Sandoval and like figure out, what's missing in terms of like replacing Crash with Dragon, and try and go down that route, because it's far better in my opinion.
Yeah, but my problem with Dragon is, on one hand, it tries to be a full-scale debugger, which isn't that simple to achieve. And the second problem is it still is out of tree. It still has this KBI problem. So at some point in time, it will run into the same problem. And just switching to another newer debugger won't solve this KBI issue. So, yeah.
But it doesn't start with GDB. That's step one. So it's
Yeah.
already monkeys.
Yeah. Comment was, doesn't start with GDB, but it's much easier. Yeah, that's true.
So one thing I would like to note is that you're saying that you're adding a new tool to the kernel tree so that it could follow the perf model, which has a version of perf tied to a version of the kernel. And this is common misunderstanding. I mean, perf, the model for perf, that's not, I mean, the fact that perf is developed in the kernel doesn't mean that it's tied to that specific version. There are even tarballs on the www.kernel.org where you can get the latest perf and run on the real Red Hat Enterprise 7, and it should work. If you ask on the command line for features that are not present on that kernel, it should bail out and say to you, you cannot do that, and the kernel doesn't support this. And you can get the perf at that time from Red Hat 7 and try to run on 6.0. And it will only use the feature that it knew at that time, and it should work as well. So just to make this clear, there's a common misunderstanding. The way that Debian ships it, it's being discussed because it's wrong. I mean, you don't have to have a perf version that's tied to the kernel and run preferentially that one. Preferentially, you should use the latest one because it has bugs fixed, like he said. And he has new features that doesn't require features from the kernel, which is even more important. I mean, you could, with BPF now, you could, let's say, with the 6.0 kernel running on some older kernel that has BPF already, have the PFK work tool, and it will be fantastic for that old kernel, because what it needs, it's available on that older kernel. But just that thing that I would like to note.
Okay, I was wondering if you know about Crash Python, or if you checked it out, because that's what we started some years ago, but it didn't get lots of manpower behind it so far. But it's the idea that you extend the Python API of GDB, that it's based on a patch set that's originally by Kernel, I think, and it's not so big, it could be upstreamed, and we didn't, as you say, it's a huge effort to replace all of the Crash functionality. So what we have been doing is that if we need some subsystem specific extension to do so automated analysis, we write it there, and we use the old Crash tool for other debugging, and it's been really helpful to have it this way in Python. It's very easy to extend. I've written there slab integrity checking that is now more advanced than the one in Crash, for example.
No, also Crash Python, yeah, I know about it. I also shortly discussed with Jeff the topic, but as you said, it requires a GDB extension at the moment, so also has the same problem like Crash. It's much better, of course. My problem at the moment is that at least in the latest version of Crash Python, it moved some code from the Python code to GDB itself. So it speeds up performance, but that spreads out all the, internal kernel knowledge over more and more projects and doesn't combine it in one. And yeah, that's my main problem. But to be honest, the best chance I see is currently moving Crash Python into the kernel to achieve what I want to achieve. Yeah, so yeah, one of the problems I also have with Crash Python is that Jeff and the others are quite silent about it. So I just found about it while preparing this talk, and the only place where I found a hint to it was in a comment on LWN about Dragon. So it's not very visible, but it's definitely a pretty cool tool and goes, yeah, pretty much in the direction I want to go, with the only exception, in my opinion, it should be scaled down to only the latest kernel version and moved to the kernel tree to be maintained there.
So
we're at about 10 minutes.
Okay.
we have.
Not very much, only one more slide, or maybe, yeah, about the upstream problems. Of course, the first 2 points aren't, it's nothing new, it's more of the same. This long transition phase will, in my opinion, also be a problem because, well, you have, once you have, this replacement for Crash in place and say, okay, now it can really replace Crash, you still need the old Crash for the older kernel because you can only support newer ones. So it's not only a multi-year project, but you also have to maintain the OSO tools for quite a long time longer until those old kernels drop out of support by the distros. And last thing I want to mention, it's about downstream problems because, well, first point is, again, nothing special because you already have the debug information perf and other tools you support for each kernel version. But when you want to have it a clean way, you always have to update your kernel together with the tools. So to get a fix in the tools, you need to update the kernel, which unfortunately is sometimes a problem for distros or for the customers of those distros. And so in this case, you have to, there has to be a shift in thinking, and you have to see the tools to be part of the kernel, and a bug in the tools to be part of it or be a kernel bug. And yeah, last thing is that, of course, as mentioned before, especially customer support need to update their tooling, need to learn how to handle non-existing features, although they might have been extremely helpful for this particular case, but they are not part in this distro kernel yet. And yeah, with this, thoughts and opinions.
So a couple of comments from the chat. First of all, I do agree with Arnaldo. So even if we move it to the kernel tree, you still have to, it has to work with the stables in the sense that in a limited fashion, whatever features. So that's kind of what we do with all the tools, including the kernel self-test I maintain. And so one comment that they have is the crash version for the kernel would probably have to ship with the debug RPM packages. We already have the Python GDB scripts of the kernel in the distro packages. I don't know if we have any thoughts on that. Was the question clear, or should I repeat that?
Yeah, can you repeat it, please?
Yes. So I'll read it as is. The crash version for the kernel would probably have to ship with the debug RPM packages. We already have the Python GDB scripts of the kernel in the distro packages.
Yes, so that's or yeah, ship either with the debug information or in a separate package. And yeah, and the Python scripts in the kernel, of course, was what inspired me, basically. So just to extend them and then combine with Crash Python to get the full functionality.
Okay,
Yeah.
that sounds good.
But it needs to be shipped, separately.
So another one, if we can merge this, some such GDB scripts into the tools directory, maybe we can also run a test script when build the kernel and ensure that it's not broken with the new kernel release. Meaning, if it is in there, then you can continuously. Yes.
Definitely, yeah, and that's what I like about this KABI checker, which gets possible with scaling down the KABIs or supported KABI, because it's a pretty cheap way to do those checks and to at least get a heads up with, hey, something changed.
Mm-hmm. So you can kind of, there is an advantages to having this in the kernel.
Yeah.
So that's kind of what it is.
And of course the fixes tag as well, because at least I don't know any option to have a fixes tag that references a commit in a different repository, but it's only always referencing the same repository. And there's also a lot of tooling in the distros about the fixes tag.
Right. So one more, we're doing a little more on the chat because we have taken a lot of questions in the room. Crash Python is also still hosted on the SourceForge, so you instantly assume it's dead. I don't know. So that's another comment from there.
Yeah.
Okay, I think that's about it from the chat.
So I love this talk because there's a lot of really important problems here that you're discussing and that we need to focus on. Dragon has the same problems with referencing commit messages from older kernel versions, and Dragon will get those same problems as Crash eventually. So this is a really important topic. So thank you for that, first of all. Yeah. I think there's a great diversity of debugging tools already. Look at tracing, look at debuggers. The fact that we're talking about Crash Python, Crash, PyKdump, Dragon, I think that's healthy. I would love for us to have this discussion rather about blessing one specific tool and picking which one that is and then maintaining it in the kernel tree. I'd rather have this discussion about figuring out how the kernel can describe for itself. How can you read my crash dump? How can you debug me better? And then let all of the tools handle these questions about, okay, which versions of the kernel do I support? I'll support all stable versions. I'll support all rel-oriented kernels, whatever they want to do, and let them have the choice to go from there. I think I would love to have a discussion about making the kernel more self-describing and making it easier for all of the tools to do this, to read their crash dumps better.
A time check, 2 minutes.
Yeah, I'm fully with you. So this is one solution I see, and at least for me, the easiest solution when you want to stay with this one tool. But yeah, other solutions are welcome. But there needs something to be done, in my opinion. You cannot just continue doing the same stuff over and over again and run into the same problems over and over again without changing something.
This will probably be the last question.
Yeah. I want to know, what have you thought about looking, I think most of the problem are in the Crash. The KDUM file is fine, I think. For the Crash, have you think about making it more modular in the sense that you define an internal stable API, and then you have high-level function and low-level function. The low-level function will be dependent on the kernel version, so you only need to modify the simpler low-level function for different kernel version instead of making changes that spread across the whole tools.
Yeah, the problem about this is that Crash isn't designed for that. So you had to completely redesign Crash, and I think Crash Python goes pretty much in this direction. But yeah, would be, of course, preferable to just have different modules and you'd only test, or you test those modules and verify those modules that they work with your kernel. Or did I get your comment correctly?
Yeah. That is the point. So you have a set of simpler function that progress with the kernel, and then the majority of the high-level code remain more or less the same. Or you can add, of course, you can update it to add new functionality.
Okay.
So you define an internal stable KPI between your high-level function and your low-level function.
So we're out of time.
Yeah,
So
it's
maybe
a little
we
bit
can continue the conversation in the
complicated.
hallway. Yeah.
Okay.
Would be great if that would work, but I think at least it's better than today, but it will also have its problem because this high-level API will also always have to somehow reflect the down or the low-level API, so that you will run into problems from time to time, but it will be better than today. Yeah. Okay. Thanks very much.
Okay. Do we have audio? We're good? Okay, good afternoon, everyone. So this afternoon, we've got two sessions. First one is Laurent Pichard, who is going to be talking about DevMKZLock and why it's harmful. And over to you.
Is the microphone working? Yep, okay, great. Right, so today's topic is probably the most technologically advanced of the week, something you're extremely excited about, rocket science, brand new, but I think it's still worth talking about. So the device resource management in the kernel got introduced quite some time ago in 2.6.21. I'm not even sure I can do the math to calculate the number of years. It's another era. And it was it came with a limited set at the time of resource management functions. So you have the DevRes core that handles all the plumbing behind the scenes that drivers are not supposed to use directly. And then you have a family of DevM functions that I'm sure most of you are familiar with today. And it was just a handful at the time. So it was handling some resource management for IO remap, including PCI, IQ, and DMA memory allocation, as well as the, what I would call the infamous DevMKZLock. I think so. Full screen. Yeah, that's better. So what happened next? Quite a few versions later, actually, to 6.28, we got the first conversion of a driver from the usual allocation functions to the DevM helpers. It doesn't mean that DevRes was sitting unused for 7 kernel versions. It was used immediately in the first patch series in the libata, I think. So there were some users, but conversion started coming quite a bit later. This is what a typical conversion looks like. I hope it's not too small, but it's really about replacing the manual functions with a managed counterpart, and obviously removing the functions that free the resources or free the memory. So as such, a typical conversion doesn't really cause a problem, doesn't conceptually cause issues. If you look at what's there, there's no problem introduced by usage of DevMKZLock in this patch. However, the reason why typical conversion doesn't introduce a problem is, the important part is the word introduce. The problems were there all along. So it's not new bugs, but it's an issue of not memory leak in this time, a resource leak. DevRes handles that. But the issue is use after free. And you typically in a producer, so typically in a driver, you will allocate a data structure, you will allocate an object, you will allocate a clock, a regulator, if you are a regulator driver, you will allocate something, and you will register that with a subsystem. And then someone, somewhere, a consumer will acquire that resource. You will have a driver calling clock get, or any other function that will acquire that. And at some point, the producer may disappear. If your producer is a USB device, you can unplug the device physically. If it's a platform device, there's usually not going to be any hardware unplug directly in most cases, but what you can have is actually unbinding the device from the driver through sysfs, for instance. You can also remove the module, which kind of does the same. And so the problem we have there is that if you unregister, when unplugging a USB device, for instance, free the memory at that point, your disconnect function USB driver returns, the DevMKZLock helper will have allocated memory that will be freed at that point. If it's used later by the consumer, you have a use after free. The typical use case that I want to address here today is a case where the resource is exposed. It's not used just in the kernel, but it's exposed to user space. So you have a character device exposed to user space through any subsystem that use character devices, lots of them. And it means that user space can open the device. And in most cases, it's going to be unprivileged applications that will be able to do that. And we'll be able to keep the device open pretty much forever. And if you then disconnect your device, when you call the close function in user space, it's going to call the release file operation in the kernel, you have your typical case of use after free. Obviously, if you want to fix that, what we need to do is not to delay the unregistration of the resource. When your device is removed, you have to inform the subsystem that the resource is gone, but freeing the resources that can still be reached by the consumers needs to be delayed until the last reference to a resource is released. So, as I said, references can be inside the kernel. I'm mostly concerned about user space because that's where we have the biggest potential for crashes and kernel oopsies by unprivileged applications, but the same thing applies to in-kernel consumers. So the question then is, well, I don't think it's an issue of DevRes as such, because when we are submitted, it made a promise summarized in the commit message that the release functions for all the managed resources would be called on driver detach. So that's what they promised. That's what they're doing, and that's totally fine. But the problem is that most people heard we're going to release them by magic at the right time. And I mentioned I was introduced in 2.6.21. Drivers got converted starting 2.6.28. And slowly over time, DevM has taken over the kernel. We have today around 170 managed helpers in lots of different subsystems. And we can categorize them in roughly 4 big categories. You have the functions that handle resource allocation. Allocating, I put a few examples for each, allocating an input device. So if you're a driver for an input device, you're going to call this devm function to allocate device for you, and you won't have to free it in your remove handler in the driver. Then we have the same thing for resource registration that saves you the work of doing the unregistration manually when the device is removed. And then we have the resource acquisition. So the first 2 are meant for producers. The third one is meant for consumers. And the last one, there are few of them, not that many, but I call that a bit of abuse of DevRes, because there are few places in the kernel where frameworks want to associate arbitrary data with a struct device. And so there's DevRes usage there to associate the data, and then they use the DevRes find function to be able to find it later. So it's kind of a free association between random data and struct device. It was there and was used for that. There's a shortage of magic. Sorry to say that, and that's not going to be the focus of the talk. I won't try to figure out how we can do magic, but how possibly we can do proper engineering to fix the problem here. But really, the question is how do we fix that problem? So I want to emphasize. I already said that the promise that DevRes made in the beginning was not bad. It was very clear. I want to emphasize that I think that totally valid use cases for those APIs. And clearly, acquiring resources that the driver model requires you to release before your driver remove handler returns, that's something that's totally fine. The driver model requires that the platform device will not touch device memory after remove returns. And so if you IO remap that with a devm helper, the resource is freed at that point. If you ever touch it later, if you have a use after free there, it means you've done something really bad in the driver in the first place because you're not allowed to do that. So for that, I think it's totally fine. Acquiring clocks, acquiring regulators, and those, fine. The tiny caveat at the bottom of the screen, actually, it would be mostly safe because we still have the issue of ordering of the release of resources. So DevRes will guarantee that they're released in the inverse order that they acquired. That's normally what you want to do. But it's fairly typical for a driver and its probe function to mix and match managed helpers and non-managed helpers, which means that when you release, everything that's not managed needs to be released manually in the remove function, and that's going to go first. And then when it returns and goes back to the driver core, all the managed ones will be released. So you can't guarantee the same order. In most cases, it's going to be okay. But you could have, for instance, the device and the power domain being shut down at the bus level after you remove function return. So out of control the driver, but at the bus level. And then later, you will have all the DevRest resources released, and that's going to free the interrupt, for instance. You're supposed to have shut down the device and you remove handler, so it's not supposed to generate an interrupt, but there could be corner cases where we actually free some of the resource and disable a few things after shutting down power of the device, and that may cause issues. I haven't been able to pinpoint any actual problem there, but that has been discussed on mailing lists before, so it could still be an issue. But that's not the one I want to look at today. We've very carefully ignored the problem, or when we talked about it, we very carefully decided not to do anything. This was discussed, the exact same topic got discussed in 2015, so 7 years ago on the Kernel Summit discussed mailing list. Actually, it was a relatively long thread. It didn't get picked as a Kernel Summit discussion topic at the time. So there's if anyone's interested to read the history, there's a link in the slides there. So what I want to focus on today is the race between unbind, also called remove or disconnect, depending on what kind of driver you have. So the race between unbind and user space closing a device node. Because I think that's, as I said, it's fairly dangerous, can be triggered by user space, and hopefully relatively low-hanging fruit. So how do we fix that? There may be people in the room who will have a very clear answer: rewrite the kernel in Rust. That may be a solution, but I don't think that can be called realistically low-hanging fruit and solved very quickly. However, that being said, it's not entirely a joke in the sense that what Rust brings is not just a language and tooling that goes around that, but also forces developer to consider lifetime management, because otherwise the compiler is going to complain. And if you get fluent in Rust and you consider lifetime management issues when you do Rust, when you write Rust code, I'm fairly certain that you're going to write much better C code afterwards. So I think that Rust would actually benefit the kernel in areas that are not just the ones that would be handled by the Rust language. Other solutions. Well, another obvious one, never free resources. If you remove the free in use after free, there's just use after, and that's totally fine. In some cases, we may be able to do that. I mean, realistically, the call clocks that are provided by the SoC, I don't think that we really need to care about the clock driver being unbound and removing all the clocks of the system. That's never going to happen. So in those cases, in those kind of really low-level drivers, you may say, okay, I don't even need to free anything, and they're actually in some subsystem for those low-level resources. You don't even have any function that will be called by the subsystem to tell you that things have gone, because they can never go away. But that can't be a universal solution. Certainly for things that can be plugged and unplugged, talking again USB devices, you clearly can't get away with that. So what else? Well, if we have to free the resources at some point, we have to ensure they are freed after the use. And one way or another, that involves reference counting. It involves knowing when nobody will use the resource anymore and when it's safe to free it. And we actually have some of that already in the kernel. If you look at struct device, it has a release function that is called when the last reference to struct device goes away. So we have that. The thing is, it has to be plumbed through the whole inheritance chain of structures. If you have a struct device that's embedded in a struct CDEV, that's embedded in a struct video device in Video for Linux, I'll take that as an example because it's a subsystem I work with very often. And then your video device is embedded in a driver-specific structure. So you have this inheritance chain, and you have to forward this release even all the way up, all the way to the driver, because at the end of the day, what allocates the memory that stores everything is the driver. So that's one option, but it pushes complexity to all the leaf nodes, to all the drivers. And I'm not entirely sure that's something that we can get away with. Can we guarantee that through some magic, all driver developers will suddenly understand the complicated lifetime management issues? Yep.
That also won't work because devices are not removed when you remove a driver binding to a device.
So there are usually two struct device instances involved.
True.
Think about a USB device. You have the struct device, I think a USB interface. So that's a physical device that you plug in and plug in your system. But you also have the struct device that's associated with the CDEV that exposed to user space.
Yes, the class view, the user space using the hardware view.
And so that's the one I'm talking about here. The resources are linked to the lifetime management of what is exposed to user space. If we have a device node exposed to user space, we need to make sure that we free the memory that actually stores that device node only when the last reference to it is freed. And so is it this struct device? And it's nice to have a single structure that can model both the physical devices but also the device nodes. But it's also, I mean, technically speaking, there are some advantages to that, but it generates so much confusion when it comes to lifetime management issues that, I mean, if you could rewrite the kernel from scratch, maybe you should do something else. But that's not going to change. So manual ref counting, even the subsystems get it wrong. These are two helpers from Video for Linux. And the bottom one is a function that is provided to be used by driver, to be plugged as a release handler, and it does nothing. So if you have a release handler that does nothing, I mean, quite clearly, there's even a comment there saying have a static video device is a dubious construction at best. Well, yes, it's very dubious. So even at the subsystem level, we get it wrong, which means that there's no way we're going to get it right in all the drivers. Other options. Something that was tried in the DRM subsystem, and I think it's actually quite interesting. There are a set of managed helpers in DRM, such as DRM-M KZLock. Despite the name and the fact that it's documented as a managed helper, it does not use DevRes internally. It actually duplicates the implementation. So you have a separate implementation in DRM. The functionality is the same. The difference is that it ties the lifetime of the resources not to the lifetime of the struct device that corresponds to your physical device. That's wrong. You don't want to free those resources when the device isn't bound. But it ties the lifetime to the struct device that corresponds to the character device exposed to user space. So that is the right lifetime. The drawback of that is, well, first of all, it causes code duplication. We have a separate implementation of DevRes in that subsystem, and you have to replicate that in different subsystems. That's going to be lots of parallel implementations. I think that could be fixed. DevRes has added a few fields in struct device to account for the resources. We should be able to move those in a separate structure. I don't know how we would call that. I don't know, DevRes owner, for instance, something like that. With all the DevRes core functions taking a pointer to a DevRes owner instead of a struct device. And struct device would embed that. So we would still have the current DevM helpers. But any subsystem that wants to tie lifetime management of some resources to a different object would be able to embed that DevRes owner in a different object. So the code application, I think it should be able to fix that without too many issues. However, with this, we tie the lifetime of the resources of the memory that's allocated to one particular character device exposed to user space. So DRM subsystem, it's your DRM driver. Your DRM character device that's exposed to applications. That's mostly fine. In most cases, it's going to be fine. But if you have a driver that has to create multiple devices, device not exposed to user space, because you have It's more typical maybe in the video for Linux side, but you have to handle a device that has video functions and audio functions, and maybe it's going to have it's a webcam with a few buttons on it, so you also need to tie it with the input device. And so all of a sudden, one physical device instant exposes an input device CDF to user space, one or multiple vFold to video nodes, and audio-related devices as well. So we cannot tie the lifetime of the top-level object that's allocated by the driver to any of those. What we need to do is to make sure that any of those character devices exposed to user space gets a reference to that high-level object. And then when the last reference to it goes away, we can free the resources. So yes, over there. Well, actually, there's a second one.
Yeah, actually, I think it's really wrong to expose multiple charge devices by my driver. For that, you have an auxiliary bus, which is supposed to solve this problem. Every charge device will be exported by one subdriver, which is connected by auxiliary bus, and so all is supposed to be released by itself.
No, that's not what auxiliary bus is for. Auxiliary bus is for carving up a physical device or a virtual device into smaller devices that are controlled by drivers. He has unique user space representations to a device that user space sees, like video for Linux. You got audio, video control, all that stuff. That's fine. Auxiliary bus is not for that. Please don't. Two different things. He's dealing with classes. You're dealing with drivers and buses. Two different things.
Right, but he started to say, at the beginning he said that one driver created multiple charge devices.
Yes.
And charge devices are created not by, when you said driver, it means it's not class.
Yes, no. He means charge devices are classes.
Okay.
Yes. That's it. They're not, it's okay. Do not use auxiliary bus for this, please. That's not what it was designed for. That's not why we added it. It solves a nice problem that we have, makes things easier for subsystems. It doesn't solve this problem at all.
Well, Greg said.
Okay.
But in most cases, a driver on one physical device will create a single device node to user space. So we could still use something like that, assuming that we could solve the code application issue. This may still be something usable, but we would need a mechanism where we could somehow either bypass that or make it possible when your driver exposes multiple character devices to user space to still handle manually or through a different mechanism the reference counting there. Another idea that's not something that has been proposed yet to my knowledge or implemented. Could we simplify the reference counting? We have a kref object in the kernel. And it's for this use case, this is something typically so the UVC driver is the USB video class driver. So that's the one most of you will be using if you have a webcam, USB webcam. Because of the nature of those webcams, I said it's video, but they can also have input devices. So that's already multiple char devices exposed to user space. But even on the video side, they can expose multiple video streams. So you can have multiple video for Linux video nodes. It could be argued that video for Linux should have a single char dev exposed to user space for multiple streams, but that's the nature of the API, and I don't think that's what we need to solve here today. So what the driver does is that it has a custom UVC release function that is plugged as the .release handler of the device. And when that is called, it's going to decrease the reference count on its own data structure. And when the reference count reaches 0, it calls UVC delete, which will just turn the light off and free the data. So that part works fine. But To get there, there were actually quite a few bug fixes that were merged over time. So the first iteration was clearly not correct, and I think that means that it's difficult for drivers to get there. So could we simplify that by? I mentioned that we have a relationship through the inheritance chain of structures. We know about that relationship. We have structures that embed each other. If those structures are reference counted, the same way that the struct device is reference counted, that video device will be reference counted, that my driver structure will be reference counted as well. When we acquire with the KRF get, basically those references, would there be a way to have a bit of a different API where we could say, I'm acquiring a reference because there's this relationship between two objects. Don't know how we would call them, KRF object or whatever. And then when you decrease a reference on an object, it would automatically decrease the reference on the other objects that are connected to that. Ideally, it would also bind the release function that you pass to KRF put at the creation of the reference, so that you don't have to remember it's in every location where you call KRF put. That gets a bit close to garbage management system, where you have objects that can have references to other objects, and then when something is, when a reference count somewhere reaches 0, it's going to propagate with the risk of having loops in the references. I mean, that's not something that should happen in these kind of use cases. But is this too close to garbage collection to be acceptable, or is it something that could be investigated? Don't really have an answer to that question. I would be willing to give it a try if it's something that, if there's an overall feeling that it's a path that should be tried. If it's considered to be too horrible, then we have to do something else.
That's going to be hard. That's going to be really hard to make generic.
Possibly.
Yeah, it might be. That scares me.
Besides being hard, if it's doable, do you think it would be a good idea? No commitment, of course.
I don't know. I don't know.
I think we have already some of it because we have the reference counting propagating through the device structures. So you have, when you drop the reference to a child device, you're gonna drop references to parent, and eventually you'll get to some of a release function that will free. I think overall, you need to separate thinking resources attached to a hardware device object and anything that you expose to user space, and they have different lifetimes, and you just need to know how to sever the link at unbind or at release time and let them go their own happy ways.
That's right, yes.
So if we can generic or make that generic, because you've done this for Video for Linux, DRM guys did it for DRM, everybody else gets it wrong. If we can have that way to bind those two things together in a simple way, then it would provide this, because you've almost done this already in your own subsystem, right?
So the example I gave for DRM with its own set of managed functions, that I think could be refactored to use a common base that different subsystems could use. So that would probably be already a step in the right direction. And DevRes would use the same. So it would be a mechanism to attach a set of resources to a lifetime of to a different object. And that could be any kind of object. So that could simplify subsystems. On the Video for Linux side, we do propagate the release functions. We do not have any managed helpers that are created by Video for Linux. So not the equivalent of what exists in DRM. It's all manual work, which means that most of the drivers, if not all, handle it wrong. So that's what makes me think that we can't really push that down to the drivers without any help. That's not going to fly.
So given,
There's also a question in the back.
Oh.
Where's the question?
So one thing I worry about every time I hear the word push it down to the drivers or what drivers should do is I worry about drivers can be in modules and modules can get unloaded.
Yes.
And so even if a driver tried to do this right, I could imagine them still getting it wrong because they add their, different dev managed free function, and they say, well, when the character space device goes away, I call this function. Well, by then they may have been RM modded, and there may be no code backing that function anymore. So to some extent, I almost wonder if instead of extending the lifetime, it's almost handing off ownership. Like I'd rather see the ownership of the care device go from being managed by a driver saying, hey, the driver went away, just put a bogus, core managed care device in its place that just returns E and val every time. But at least it doesn't totally die.
If it were just for the CDEV, maybe we could have a look at that. But the problem is that what's allocated by the driver, usually you have a top-level structure that's going to embed lots of things. Not a CDEV directly, but a video device, an input device, or whatever that has a CDEV inside, but also different things that are allocated by the driver. And so you need, I don't really see how you could pass ownership of all that to some other code and still have the ability to shut down things properly and free the resources there in the right order and know what to do, unless everything was going through managed APIs, possibly. But back to your point about driver unloading, I don't think that's an issue, because as long as you have a device node that's opened by user space, the reference count on the module itself is increased, and so you cannot unload it. What you can do is to go, if it's a USB device, you can physically unplug it. But driver is still there, so it means that the disconnect function of the driver will be called, and when that returns, when the disconnect function returns, the driver will still be there until the last user space file descriptor is closed. The driver has to guarantee that it will not try to access the device anymore. So anything that comes from user space at that point needs to make sure that it will not try to issue or to send a USB request, for instance, to the device, because you can't do that after it has disconnected. But you still have the code from the driver that's there that can handle at least all the cleanup path. So that's a separate point I listed on the last slide. This is the race between unbind and close from user space, but you actually also have a race between unbind and usage of the device, because if you have a system call, a file operation that comes from user space that is being executed, and you unbind a driver at the same time, those will race each other. And it's very difficult to guarantee in your system call handlers, the IOCTL handlers, the read and write handlers, that it will do the right thing everywhere if at some point the disconnect handler pulls resources underneath it. It's possible to some extent through proper locking, but I'm pretty sure that all drivers will get that wrong as well. So that's something else. There's a patch I posted a while ago, I think it was Dan Williams, I believe, who also posted a patch last year to improve the CDEV layer. We had a discussion, I think, Greg, on the mailing list. He said you would have a look at it on the CDEV side, but Dan actually posted patches a year ago, so maybe we could revive that. But that's a separate race condition that I think we should fix as well. There's lots of race conditions.
Yeah. So just that reminds me of an old discussion we had. If I remember correctly, we pretty much gave up on module removal, because we never got that ref counting right anyway. And so as far as I know, unless we change something here, the official policy of the Linux kernel is module removal is not a supported operation. You can force it, but it is not an officially supported operation. Have we changed that statement? No. Okay.
In RDMA, we dealt with and solved all these problems in various ways, and module removal was a customer use case. We actually needed to hot unplug a driver and leave behind, like you talked about, like a stub where the char dev returns, no dev everywhere. And it's very complicated, but like if you do your layering properly and follow normal idioms, it's achievable.
So, this always comes up of if we do it properly, and it's never going to be done right if it's just based on reasoning to get it right. What tool is there tooling that can be done? Is there ways to implement the API so that when it is done wrong, because it will, we can find it?
We're discussing with Greg earlier. Maybe we can get help from our friends on the compiler side. The typical characteristic of something that has its own lifetime is that there is a caref in it. So maybe we could come up with some form of compiler plugin or something that spots that we are assigning the output of a devm function to something that has a caref in it. And that is probably always going to be incorrect. And so we might be able to find ways to at least detect them, if not automatically fix them, but at the very least detect them that way. It's a little bit fiddly, but from some of the discussion we had about compiler things this morning, apparently the idea of inferring the L value of an assignment is not that far-fetched from compiler plugins. Keith Cook was mentioning things like this. So that's just food for thought, but that might be a way to, at the very least, identify them. I was beaten by this myself on code I wrote, right?
Yep.
I put
We all have it.
in dev allocated structures and wonder why everything was exploding in stress testing years and years ago. So it's a very common pattern, and it's always broken.
Yeah.
So this all assumes that like the struct video device or struct chardef is embedded in the what you call the top level structure. But if you look at how input devices work, the dev input stuff, evdev, you actually always have to dynamically allocate it. And when you call free, it actually doesn't do a real free, it just does a put. And it leaves a stop behind, which is dynamically allocated and managed by the input layer. So user space can still, as long as it's open, it can still do ioctls, but it will just get an error because it knows under the hood that it's been disconnected. And even you could error mod the driver which registered the input device because the memory is being managed by the input core layer. So they really have like this separation of the class device, as Greg calls it, is managed by the input core. And we could do something similar in video for Linux, where you always have to dynamically allocate your video dev. And then the lifetime of the video dev gets owned by the core, and the driver just says, sorry, I'm gone. And all the ioctls will just error out.
There's an issue with that, at least at the moment in the kernel, in the sense that you would need to guarantee when you severe that link that you're not executing an IOCTL at that point. So it's not really about the user space keeping something open for a long time, but you need to make sure that the system calls that are currently running in the kernel need to return first before you do that. So you need to wait for that. And that's the patch series I mentioned. I think that's fixable. There are some system calls that are blocking as well, blocking in driver code. So we will need to make sure that at unbind time, the driver will wake up anything that's being blocked to make sure that those code paths can return. So there's a bit of work that needs to be done there, but that I think is totally doable. And then we could also indeed look in that direction. But I hadn't thought about tooling. I think it's a good point as well. My kind of default assumption is that we have to try to make APIs that cannot be used wrongly, or at least cannot be easily used wrong. But tooling is, when it's not possible to create APIs that can't be used wrong, I think tooling is also a very good idea.
Yes, or simply because even if you create a new one that's great, you still need to find where the existing bad cases are.
Yes. So. Yes. Well, everywhere.
All right, we've got about 5 minutes left.
Okay.
I had a quick question. So it's a hacky thought, I guess. So devm, right? One way to look at it is it only has one ref counter there, right? It's tied to the device. If the device goes away, it releases a reference, it's gone. That works as long as you're not interacting with the user space directly. Can we have like a big hammer kind of function saying, hey, this device might interact with the user space with this file descriptor or whatever, and you can kind of plumb it in so that just goes and increases the reference count for all the resources the device holds. And then when you close the file, you go release it all. So, for example, in the video for Linux case, you would give the parent device that's holding the devres or devm-based resources. That wouldn't be like a perfect granular fix, but would that be something that could work?
So
it's almost like copied user for copy from user, not in that sense, but anytime you interact with the user, you're saying giving to user or taking away from user kind of thing.
So we have the ability in the kernel certainly to track that and to know when, a CDEV is reference counted, or the opens from user space are reference counted, so we know when user space will close the last file descriptor or unmap the last piece of memory. So that we have access to. And in the video for Linux case, we have those release handlers, and then you have to plumb that all the way through the driver, as I explained. So that's that's where I think it doesn't scale. But the infrastructure is there, and the helpers in the DRM subsystem, I think, do what you described by tying the lifetime of those memory allocations or those resources that need to track the lifetime of the CDEV and track the lifetime of the user space access, tying them to the proper object. So I think that is doable, yes. With the caveat, as I mentioned, that if we have multiple CDEVs that are registered in a single driver for a single physical device, then that's not gonna work, I think.
Yeah, that's what I was saying. You can still tie all of this to the main device that created these instead of the CDEVs. It's not granular like we'd like it to be, but no.
We can't do that again. You have classes, which is the user space representation that the CDEVs that also happens to be called a struct device, sorry. And then you have the devices on the bus, and that's where the resources like the clocks and the interrupts and everything again. There's two independent things here.
Right, I'm asking you to tie to the real
No, I'm
device.
trying to say we need to sever that tie. And they're independent. I mean, like Willie just like jokingly say, we want revoke, right? We want to revoke for forever. It's a kind of a revoke when we know this device is going away. We want to call back and revoke everything and clean everything up properly. And revoke is impossible to do. We keep trying it. If you look, even the BSDs just do it for one single character type. So nobody's really done revoke.
Cherries. What I was trying to say was that revoke is really hard, and I think a lot of the solutions being proposed here are the same complexity as doing revoke, and we've been looking to do revoke for over 20 years and we still haven't done it. So it's really hard.
I think maybe something practically that could be done is to maybe document the successful idioms for how do you structure the code, where do you put the functions, what do you call the functions, how does the control flow work in a way that we know works. Like we have examples that do work. People have built simple examples that work. At least then it gives the humans the ability to audit the mess, right? Like if you have a dynamically allocated structure with a kref and a release function, we know that the release function should free every member of that structure, and it's at least auditable.
We need good examples, good documentation, so that we'll know that nobody will read them, but at least we'll be able to point people to it.
At least you've got a common understanding, because right now, like your slides show that different subsystems are doing different things, solving the same problem in different ways.
Absolutely.
And the different solutions have known challenges, right?
My thought is if we manage to move toward a world where the release function is embedded in a kref, which makes things easier, we could have a variant of devm kzlock where we provide that kref, and instead of freeing the structure, devm will just dereference it. We do? Okay, I thought we just pass it every time we call kref put.
I have to double check that.
I forgot. It's been a while.
Greg said every char dev has a struct device associated with it.
Yes, then
because it's the class, and the class's release function acts as what you're asking for.
Sure, but okay, but devm doesn't know whether what you the char dev or something else.
Right.
The char dev is just one case of problem here.
Well, devm doesn't work at all on anything that's not a physical device because it's
Correct.
tied into the.
My idea was simply to, instead of using an devm allocate that we do a hard free, we do a devm allocate, then just drop the reference. But to do that, we need to know about that reference sufficiently.
Yes.
And so we could just have a charter version, but that's kind of a bit limitative. Anyway.
I think you actually have hit on something here because it's.
We're going to need to wrap up. Any last comments, Laura?
Yes, just to mention that there are more issues already mentioned, the race between unbind and ongoing system calls. I wanted to point on the last slide. Here has two links to mail threads about that, 2 different patch series. So I think that would also be a very good candidate to resume the work on that, because it's a real problem. You can crash. When you unplug a USB webcam, you can trigger a crash from user space actually because of that. I mentioned also the ordering of the devs release, and that thing about severing the link or revoking resources. Could we do that for clocks, regulator, GPIOs? Probably not. I'm a bit sad that those drivers, I think, will never be able to fix the problem there, and we'll have to live with the fact that they have to stay there forever without being unbound properly.
All right. Thank you.
Thank you.
Okay, SJ, where are you? Next, we have SJ Park, who is going to be talking about the daemon system. And over to you, SJ.
Okay, thanks for the introduction. So first of all, the disclaimer, so all the opinions are my own, not my employer. And to introduce myself again, so my real name is Sungjae, and you can just call me SJ, or whatever better for you to pronounce. And I'm currently working as a kernel development engineer at Amazon Web Service, and having interest in the memory management and the pair programming side, and currently maintaining daemon. So first of all, the overall motivation of the work which I will introduce today. So the main goal is to develop the access-aware Linux kernel. So the motivation starts from the trend that DRAM is a major infrastructure expense of today. And we can reduce the expense by improving memory efficiency. And for that, we can do that if we can make better data management decision. And for the better data management decision, we need to estimate the data access pattern of the future. And because we cannot be the fortune teller, we can at least aware of current access patterns. And if we can do that in efficient way, then we can operate the system with the information. And of course, the Linux is already some access-aware OS kernel, but apparently could do something better. And we could make it highly user space controllable while making it just worse in many cases. So the overview is like this. First of all, the motivation of the daemon. So I just told that we need to aware of the data access pattern, but data access monitoring overhead is usually high and also unbounded. It's usually high, and such a high overhead can also affect the monitoring research accuracy. For example, if we want to scan all the access of the memory once in a while, and if it cannot finish in the time that we want to finish the scanning, then the accuracy could be something that not what we expected. And so I sometimes feel like that maybe a kind of the uncertainty principle can be applied here. And the unbounded overhead is inherent in fixed granularity monitoring, in my opinion. As the amount of the data to monitor increases, the monitoring overhead should, of course, grow as well. And that said, the high overhead is inevitable for precise and large amount of information. That's the nature of the world. So, but do we really paying for only what we need in real? No one price plan fits all, and therefore, and also I sometimes feel that there's no simple and centralized interface for data access monitoring in Linux kernel. Therefore, I have started developing the data access monitor called Daemon. This is a data access monitoring framework of Linux kernel, and it aims to be the simple and centralized access monitoring interface I just described. It allows users to know which memory area is how frequently accessed and how long the access frequency has maintained. It lets users to set the minimum accuracy and the maximum overhead, and then make its best effort trade-off of the accuracy and overhead within the user-specified bound. And for this, we can implement multiple trade-off mechanisms, and we can selectively use some of that can fit for the user. That said, at the moment, the adaptive access pattern-oriented regions adjustment mechanism is the default and single mechanism for this of Daemon. And for details of the mechanism, you can refer to the kernel documentation or Kernel Summit 20 Daemon talk that I have made. So this time, in this talk, I will just introduce the status and discuss about the plan. So I will not discuss about the detail of the mechanism, but the default mechanism allows the bounded overhead regardless of the monitoring target memory size. And of course, it sacrifices some of the monitoring research accuracy, but it's a best effort. And for example, and also for the other trade-off logic, we can think about, for example, page granularity monitoring mechanism, which can provide at some level of accuracy, but of course it would have unbounded overhead, but that could be done. And also we have some experimental implementation before, though it's not merged in the mainline at the moment due to the absence of the real use case. And also it allows very easy extension and flexible customization by the design of the separation of the layers of the logic and monitoring operations and interface. And the evaluation, so we have evaluated daemon using some setups, and on a production setup, we concluded that daemon is lightweight because on the production setup, daemon was able to check access to entire system memory every 5 milliseconds in concept. So it's not really scanning all the access of the system, but every 5 milliseconds, it can conceptually scan all the monitor all the access, and it consumes only less than 1% single CPU time. So nevertheless, please note that the daemon overhead does not increase as the memory size increases as long as you are using the default trade-off logic. And also we conclude that daemon is accurate because we have shown some same monitoring research with the realistic benchmark workloads and also from the production workloads. From the production workloads, we were able to find 7 GB working set among the about 70 GB of the entire system memory. And also we were able to find 4 KB hard disk region. And the same monitoring research was something like this. So these are showing the access pattern of the 25 benchmark workloads in heat map format. And also by identifying the hot memory regions of some workloads from daemon research with our human eyes and then modifying the program to protect the hot regions using MLOC system call, the region, the workload has showed over 2 times better speed under some artificial memory pressure. So daemon, the first RFC patch of the daemon has posted in January of 2020, then merged in the Amazon Linux 2 kernel and then mainline by 5.15. And recently it has also enabled in Android GKI. So we now have the daemon, which is providing centralized, simple interface for memory monitoring with low overhead or at least reasonable overhead. So now we can do the daemon-based optimizations by both kernel space and from the user space. And some of these steps for this work would be very common. For example, the user or kernel program should run daemon and get and analyze the monitoring research and make some memory management decisions. For example, finding cold pages and reclaiming, finding hot pages and applying transparent use pages or whatever. But this situation is not so ideal because some of these steps could be repetitive for some different optimization approaches. And also user space approaches could be inefficient due to the kernel space to user space context switches because daemon is running in the kernel space and the user space program should of course work from the user space. And of course we can optimize this by using BPF-like approaches. But what I was thinking about is that couldn't we offload all the works to the daemon in the kernel so that we don't need to repeat ourselves and use the information that generated by daemon inside kernel directly from daemon inside kernel. For the region, we have made a feature of daemon called daemon-based operation schemes, or daemons in short. This is a core feature of daemon for reducing the repetitive works I just mentioned. So it receives inputs called schemes, and each scheme is constructed with target access pattern, which is constructed with 3 ranges of size, access frequency, and age of memory regions that it monitors, and memory management action, which can be, for example, page out or huge page. Then after receiving this kind of inputs, daemon automatically runs daemon and analyzes the research, finds the memory region of the target access pattern that specified by the scheme, and then applies the memory management action also, which is also specified with the scheme to the found regions. And therefore, now users can make daemon-based optimizations with no code, but just simple configuration like this. So we have evaluated this use by re-implementing main concept ideas of two state of the similar access-aware memory management optimization works with demos. And the first one was access-aware THP collect split. This is first published in OSDI 16. And the main idea is to find hot pages that accessing two or more contiguous memory region, and then apply THP and vice versa to reduce the memory footprint bloat due to the internal fragmentation of the transparent user pages. And we have re-implemented this as just 2 lines of demos config, and our re-implemented version removed 76% of the THP memory bloat while preserving 51% of THP speedup. And secondly, we also re-implemented the main idea of the project reclamation, which has published in ASP+ 19 and currently still known as to being used by the Google fleet. And we were able to re-implement this with only 1 line of demos config, and with the re-implementation, we were able to reduce 93% of residential fetch and 23% of system memory footprint, while incurring only 1.2% runtime overhead in the best case. Actually, this is only the best case, and the workload that we have used for this evaluation are Parsec3 and Space2X benchmark workloads, which are known as realistic but still benchmark anyway. And for more details, you can download the slide and go to the detailed report in the link. And also, that was the main idea of the demos, but we felt that it's not enough for production usage, because for productions that safety critical, demos could sometimes incur large overhead due to some wrongly tuned configs. For this, we have implemented time and space quarter per a given time interval. Once these are set, demos will try to use only no more than the user specified CPU time than the given time quarter. And also, it will try to apply the memory management action to the memory no more than the space quarter that specified by the user. And also, once this quarter is given, then we should now prioritize under the quarter which region we will apply the memory management action first. And therefore, we have implemented regions prioritization feature. Under the quarter, they must apply the action to first prioritize each found memory regions of the target access pattern, and then prioritize each region, and then apply the action to the prioritized regions first. In case of the reclamation, we can make the demos to apply reclaim action to older and colder pages first. And in addition to that, we also provide 3 watermarks, which is very similar to the traditional watermarks mechanism, which can be used to let the demos just shut out and do nothing under a peaceful situation. And we also now support online tuning. The daemon didn't support online tuning at the beginning, but now it is supporting online tuning. And therefore, combination of the online tuning and these features makes open some interesting capabilities. For example, we can dynamically adjust the quarters and prioritization so that we can make some funny research. The history and status. So we have posted the first version of the RFC patch in February of 2020, then merged into Amazon Linux and merged in mainline by 5.16, and also recently enabled in Android GKI. Next, daemon modules. So from this point, as we now have the daemon and the daemon-based optimization available in very easy way, there could be some questions, which is very common in many cases, where the policy of the optimization should be. So in this case, the policy should be the daemons configuration and quarters and such things, especially the target access pattern and the action. So this is a very common question, but in my humble opinion, the 2 opinions make sense in many ways, because only user space policies could make ultimate research, because there are obviously some information that user can know better. So this is very true for some case, but I think that it might not be true for some other case. For example, in case of some key value storage like DBMS, we cannot know what next user's queries would be, and therefore we would not be able to really estimate the future access pattern in some cases. And also it requires non-trivial user space effort investment for the ultimate user space policies development. Meanwhile, the kernel space policies could be worth to try because it would be useful for someone who cannot get help from the user space ultimate policy. And also in that case, the kernel would just work at least reasonably. So we aim to convince both sides. For that, we provide the highly tunable and flexible user interface via CSFS interface. And also we provide Deimos application static kernel modules for general use case. So these are just a static kernel modules that using daemon and daemon as a framework and using the Deimos feature using the framework. And it's supposed to be useful in general case without complex tuning. For this, we provide very conservatively tuned default values that are supposed to make no fantastic benefits, but some of benefits, or at least no harm in general case, while we still allows it to be highly tuned via module parameters. So as an example, currently we have a couple of daemon modules. First one is daemon reclaim. It's daemon-based proactive reclamation kernel module, which finds code pages and proactively reclaims. Basically very same to the previously I introduced Deimos scheme I just shown. And it has written using Deimos simple kernel API, so accepting the code for the module parameters, it has only 188 lines of code, and I have once live coded this almost a similar one in 10 minutes at last year Kernel Summit. And it aims to be used on the production. For that, it ensures the safety using the quaders and watermarks features, and the quaders and watermarks are conservatively tuned, as I just mentioned, so that it makes no fantastic benefit, but some benefit in general case without harm. Next daemon module is daemon error sort. It's yet another daemon module that finds hot pages and cold pages, and it's very simple. It just calls mark page access for hot pages or folio mark access, and for found cold pages, it just calls deactivate page. Other than that, very same to the daemon reclaim, but with our evaluation, it's shown reducing 10 to 20% of memory pressure store time on the artificial memory pressure. So daemon reclaim first version of the RFC patch has posted at June of 2021, and then merged in Amazon Linux first, and then merged in mainline, and also enabled in Android HKI. And daemon error sort has developed relatively recently, so I have posted the first version of the RFC 4 months ago, and then merged in v6.0 of mainline. So something more. So this is obviously the Kernel Summit, but I also want to say about the status of each user space component and also development environment. So for the user space applications, Daemon provides two user interfaces based on debug.fs and sysfs. Those are not for manual hand users, but for user space tools implementation. And the debug.fs interface will be deprecated after next LTS is released. I don't know when the next LTS will be, but maybe 6.0 or 6.1. Anyway, the debug.fs is not so good, so please don't try that. And I personally developed and maintain my own user space tool, which is also marked as official user space tool. It's available at GitHub and PyPy, and it provides all Daemon features with human-friendly interface. And also, seems like I'm not the only one who are using Daemon. So Alibaba has also developed their own Daemon user space tool and open source at GitHub. And Daemon testing, for testing of Daemon, I am maintaining open source test suite for Daemon that I have developed on my own. It provides functionality tests and performance tests. and we run the function test for every update of my own hacking tree and 5.15 and later stable tree update and MM1 table and the mainline updates. And also I run the performance test for latest my hacking tree every day in evening. That's my routine. And also we did some forging tests using SysColor. For this, we have made the daemon debug.fs interface SysColor description and also upstreamed that. Nevertheless, we didn't have a time to implement the SysColor description file for daemon sysfs interface, unfortunately. And we also have a community. So because this is a part of Linux, we are working in community-driven way. So daemon is developed by its open and hopefully inclusive community. For this, in this community, several people, institutes, and companies are participating now, and we have the dedicated open mailing list. Daemon at least the links are there, and also we recently started hopefully open, regular, and informal virtual bi-weekly meeting series for having some more communications, and we aim to use this to be for aligning different participants' conflicting goals and reducing duplicating works and prioritizing some to-do items. And also, we will have an in-person instance of it today, 5 p.m. at meeting room 9 as a BOF session. So if you have interest, please welcome. Yep, that was the current status of this work. Now, future plans. So first of all, we need to extend daemon for some different use case. So currently, daemon is supporting virtual order space, monitoring of virtual order space and the physical order space only, but it is designed to be easily extended for various order space and use case. The support of the virtual order space and the physical order space was possible because of this design in relatively low effort. And for example, some imaginable extensions would include some more efficient page granularity system monitoring. So currently already daemon supports page granularity system monitoring, but it's quite inefficient in terms of memory usage, but we can make some more efficient version of that. And for that, we have already implemented some experimental version, but we haven't had time for testing that so much. And also we haven't found a real usage of that from other users so far. So we haven't merged that yet, but there is a proof of concept implementation already. And also we could imagine some monitoring operations using AMD IBS, the instruction-based sampling, or even we can imagine about using the LRU information as the access frequency. For example, we can simply saying we can just report to users that this page is very hot if it's in active list and marked as reference, and warm if it's in active list and but not marked as reference, and cold and cool in active list pages in similar way. And that might be a very easy way to extend daemon and let it convince some people who are still having love in LRU list mechanism, and also it could work well as soon as we evolve LRU list mechanism as well. And also it should be a very easy way to support the C groups. And also we can further imagine about read-only monitoring, write-only monitoring, C group-based monitoring support, and monitoring of specific file vector memory or etc. Secondly, we could also improve the daemon accuracy overhead. As I told at the beginning, daemon provides its best effort control of accuracy and overhead, but definitely we can do that much better. For example, we can do the adaptive monitoring attribute adjustment and region splitting in more adaptive way, for example, finding struggling regions and applying more aggressive adaptation approach. And of course, we can, and for this, we need some, first, the idea is very simple, but before starting this, we want to have some reference implementation that could incur some high amount of monitoring overhead, but provides much more accurate monitoring research. For this, we
are gonna implement the efficient page granularity monitoring in this time. And also we can think about remapping the regions based on monitoring research to sort it by the handles that we have monitored. In this way, so further, I wouldn't explain about the detail of the basic technical detail of the default daemon logic for control of accuracy and overhead, but it depends on some level of spatial locality assumption, and some people always complain that the assumption would not make sense in many cases. But I think by sorting the memory regions based on handles, and if in that way we can increase some of the spatial locality, and for this maybe we can even imagine about daemon internal middle order space for this. And also we are planning to implement daemon's allow list in deny list. Daemon is very simple because it also means that there is no special care of some special pages and case. For example, it has no special care of anonymous fileback and signals case, but it just cares about only the access pattern. And the user knows some important memory areas that shouldn't be distracted by daemons. Not only users, but also kernel knows that some memory areas are not assumed to be paged out or having any distraction from daemons, although it is found to be cold or very hot. In that case, the users could do the madvise or mlock system call or somewhat to prevent such a situation, but we can make it more easy by implementing allow list and deny list for daemons. And also, another plan is to implementing more daemons actions and modules for some other memory management case that can be helpful. So daemon might be able to be used to help efficient but still performant KHP promotion and demotion, as I shown the evaluation research of daemons before. And also, we can use daemon to find cold pages that might be not pinned because not accessed frequently, and then use that information to use as the first page migration target for compaction or CMA. And also, we can think about tiered memory management. And furthermore, currently, daemon modules are exclusive at the moment. That is, daemon reclaim and daemon LRU sort are not working together. Once we enable one thing, then the other thing should be disabled. But it would be better to unify all the modules because those are not the modules that we can imagine. There will be more modules, and it would be better to unify all the modules. For example, the daemon-based THP and the proactive reclamation or LRU sort could work well together. For example, and in that way, maybe we can just make the just working kernel that can be enabled with only one single kernel config. And of course, we will still make the behavior to be consistent. And there needs some more detailed works to do, but I believe that's doable. And daemon auto-tuning. So daemon provides not a small number of knobs, and some people are complaining about that because the tuning effort is not so trivial at the moment. And therefore, I'm planning to add in yet other more but intuitive knobs for auto-tuning other knobs. For example, just a monitoring time quarter for auto-tuning of minimum and maximum regions number, which is not so intuitive to tune. And also, we can think about the transparent memory offloading like auto-tuning idea for daemon reclaim. So the main idea of the transparent memory offloading is to monitoring pressure store information from memory and then adjust the aggressiveness of the proactive reclamation. And because daemons provides the quarter
feature, we can use the quarter feature as the aggressiveness control feature. And of course, we can also monitor the PSI. And for proof of concept, we have also run very maybe too simplified version of the TMO in each way. And then we have compared its results when it's running on its own and when the daemon error result is running background. And when the daemon error result is running background, the PSI has reduced 10 to 20%. So it might make sense to pursue this way. And also, we believe that it might be able to be generalized for general Deimos schemes. And this is already available via online tuning. Users can do this from the user side and tune the parameters online, but why not make kernel just work? So maybe we can provide some feedback interface for user space and let the users to put metrics like PSI, but not known by kernel, but only the user space knows via the interface. And then Deimos can do the auto-tuning of the aggressiveness and some more parameters based on the user-specified metric value. And also, we can allow some special keywords for kernel better known information metrics like PSI or something. And some miscellaneous to-do items. So we have discussed about what to do next with several people and companies in Daemon community. And some items that we still have on the list is non-root users use of Daemon, and Daemon running on no KDaemon. Currently, Daemon is running on a dedicated kernel thread called KDaemon but there
documentation page on top page. And it's really, it's just relatively clean. You can see what you find, library, language reference, usage, so on and so forth. It's all pretty clear on, whatever you're looking for, you know pretty well which direction you should go to try to find it. So I pulled up the front page of our documentation that's found on kernel.org, and it looks like that, which, looks kind of neat if you start looking at it. We lead off with licensing, which I'm sure is the first thing that anybody to find kernel documentation is looking for. We may not want to do this. It's safe for me to say this because I know Thomas is busy defending his work in his other section and won't give me a brief for talking about that. So that's a start, but then just go and tell your browser you want to print that front page of our documentation, 26 sheets. That's our front page. That's our main directory. Documentation. We print to a small book in its own right. It's not going to be really an easy way to find what it is that you're looking for. I think that we're missing a little bit in the way of structure there.
I think. Oh, are you presenting through BBB or are you presenting directly?
No, this is BBB.
Okay, because the mic on this thing is on. Where's the mic?
If we go out of, it was in the full screen. So if we drop it out of full screen, which I assume we do
Yeah, exit
there,
full screen and turn off
and
this
mute
mic.
that. Organize things by the audience rather than by the convenience of the maintainers who are writing it. And we've made some progress. We have these various books, as you might call them, the admin guide, the process manual, our core API manual, and so on. So some of these work a little bit better than others, but we've started to impose at least some structure on the documentation as a whole, even if, as I like to describe it, we've taken one big messy pile and turned it into a bunch of smaller, almost equally messy piles. But we're starting on that. So that is progress. This is a proposal that I put out a week or so ago for a redone front page in the way I think that we could do the front page of our documentation. I didn't get a lot of comments on this. I mostly got Torsten, who took a look at it, but otherwise, nobody else really had much to say about it, which I take as absolute permission to do anything I want. But I would actually like it if people would look at this. Now, I will put out a new version of it sometime after I'm done going to conferences, that we can do it again. Because, again, this is our introduction. This is how new developers or somebody who is trying to figure out something with the kernel comes in and sees what we have. I think it should be the best that we can make it. It's the starting point for the structure overall that I would like to see us impose on our documentation. So if anybody has looked at it and has comments now, I would sure like to hear them. Otherwise, I would like to hear them on the mailing list afterwards.
So where did the licensing go?
Where did the licensing go?
Well, we don't want it to
licensing-
be, like you said, number one, but it's got to be there, and it doesn't fit into users.
Yeah, I ended up kind of putting it in the bottom where I shoved things I didn't know quite what to do with.
Perfect.
You know, it's important. It needs to be there somewhere, but not everything can be on the front page. Licensing arguably should be, but I don't know. But it certainly doesn't need to be the first thing that we do.
Could we collect stats on which ones get visited most often and then prioritize based on where people are going?
I could talk to Constantine and see if I could get that kind of stats for the, for the version that's hosted on kernel.org. Of course, we have no stats on what people are reading on their own systems out of the kernel tree, that sort of thing. I organized it, putting the process manuals first, mostly because the one that we refer people to more than anything else is submitting patches.
Correct.
Yeah, we're always telling people to read that and read it again because they didn't read it the first time, that sort of thing. So I started with that. Torsten was actually saying that we should have the user-oriented stuff first because it's the kernels for the users. So we can argue about that. And the organization, I think it doesn't matter that much as long as it is sparse enough and focused enough that that people can find what they're after, even if they have to scroll half a page.
My comment on the ordering on that is we already have users, a lot of them, but we want to get more developers. So let's leave the developer stuff at the top.
Mm-hmm.
Okay. +1 on heading in this direction of, segmenting things. And so I'll go do the deep dive. I missed this came through the last week. But one of the areas that we're working on, and there's people that will probably contribute, is in the safety and the analysis information on how to look at the kernel from a safety perspective. Where would that fit into this type of structure, you think?
So what sort of analysis information I didn't quite catch?
Safety. So basically how you're sort of structuring, how do you go about collecting traces? How do you go about analyzing the workload? How do you go about looking at the architecture of the kernel and some of the interactions and interferences?
Well, first we have to actually have that kind of documentation.
Oh yeah, so the question here is if we can start to get the ELISA community participate, as they're doing the analysis, giving them a place to put this stuff, we can collect it, but it doesn't fall quite into those categories you've put in there.
I mean, the closest would be the process manual for now, but we perhaps could really make a good separate how to do kernel development section, which is a little bit different than.
Yeah, that's different than what I'm asking for, which is how to analyze a kernel. Well, yeah, here. Oops.
Yeah, don't throw that one.
Yeah, that can just be an extra section if we have enough content for that.
Well, I think
Wait,
we've got
for
to, like, I'd like to get a structure so that we can get people to put content in.
Yeah, or can we maybe have a section for like manuals and how to, and people can then put like specific things like how to analyze crashes, how to do some other specific things.
Yeah, tasks,
That would
basically
be
the
really
analysis
nice.
tasks. Like, we've got a lot of tools that developers are using for doing tracing and debugging and testing. And, where can we make sure that they can find this type of thing? Like, one of the things we don't have is, hey, I want to help with the kernel. I don't want to be a developer. I want to be testing it. Where do they find that?
Yeah, I mean, for the moment, you find it here in this development tools and processes section. If the nice thing about this is we can change it. Once we have the documentation, if it doesn't fit, then we can find a structure that it will fit into.
Yeah, one thing I suggested in my reply is that the structure should help making sure what you write, because what you're asking for, is it something for users of the kernel or developers of the kernel? Okay, so yeah, I think you replied to my mail, so maybe we really read users API for user space and multiple sections for developers, but not too much because otherwise it gets too messy again.
So if you go back to the Python page, you'll notice that there was 2 columns.
right?
On this page, the right side has basically no information.
Yeah, some
So
of
could we
that.
make one developers and one users if that's our main two groups? And then we'll like stuff, legal down the
Yeah,
footnotes somewhere.
we could do that. To change this requires doing Sphinx theming work, which we can do, but somebody needs to actually do it.
Yeah, and it's going to look like crap in VI.
But yeah, I mean, that would be a good thing to do. We're not stuck. I mean, we're definitely not stuck with the read the docs theme, which the original page I showed you used. I'm using a different one here, which I'm not really saying is better. But the one we have is really ugly. And I think we could do better. And while we're at it, we can make it really match what our needs are.
I guess the other thing is, if you look at the modern interfaces, they have like the 3 lines, or they call it the hamburger or whatever, and we could collapse it over to give a full view of what's there, and then we could have 2 columns that are bigger.
Right. And yeah, we can work at that. Again, you can do this. Remember, we're dealing with a big body of plain text documentation. This is just what Sphinx renders it to.
Yeah.
And so we can change that, but somebody has to put some effort into doing that. And given that we've kept our horrific, ugly theme for years with nobody really trying to change it, the energy for that seems to be relatively low.
Yeah, people need to remember that we have multiple goals here. Right now, one of the goals is that we have a single set of RST files, which should be easily readable in plain text if somebody just reads it using a text pager, that it can be formatted into a single big printed book, although I don't know how often people actually do that, and that it can be rendered as HTML. Now, we can revisit whether or not that needs to be a requirement, but that is one of the reasons why it drives the current look, right? And so there are all sorts of really modern things we could do with web design, but it might compromise some of those other goals. And maybe we should do that for the front page, right? But that's a discussion that we should probably have.
Well, that problem's probably already solved elsewhere too, right? Like we were looking at the Python page. What did they do for that? Is there other examples that people like better or worse?
So go look at the Zephyr page, okay, which is another, another OS, and it's got a much cleaner structure to navigate into, and has some of the concepts. On the other hand, it doesn't have some of the things we're looking for from the ELISA side. So 6 of one, half dozen of another. But if you're looking for an example of one way it could be structured, that's one to look at too.
Yeah, to a certain extent, we can do our web page design and our theming independently of the plain text documentation and keep both. I mean, we do need to keep both. I think the plain text side of it is a pretty hard requirement. Certain people, I think, would probably bomb my house from orbit if I tried to get away from that. But we do have some flexibility there, but it takes somebody with the time and the effort to do that work. And this seems like a really ideal job for somebody who's not a kernel developer to help with the process. It seems like we ought to be able to find someone who could do that, but that person hasn't come along. Right.
The other topic that's pretty hot is security. How are we showing the security and how to do best security best practices here?
Yeah, we don't have much about security in there at all. Again, that's missing documentation. We had one in the back there for a while.
Yeah, oops, all right. I was curious as far as for render targets, having the web is, I think, useful for people to find on the web. If we're trying to get folks who are able to help contribute that are maybe not kernel developers, has anyone considered kind of a more wiki-style editing tool that might be able to submit patches to a mailing list?
Well, we don't have that now, and we maybe could, but again, we need to maintain the documentation as plain text files in the kernel tree.
Yeah.
So that's going to make that hard, unless we have somebody acting as some sort of a go-between.
So to answer the security stuff, we don't really have best practices on use, but most of the security documentation is using the LSMs or APIs within the kernel for security stuff. We just don't have any place for like high-level
kernel use and security best practices currently?
I don't want to interrupt your thing. I'm going to talk about something else. Just for feedback here, I think this is looking a little better than the existing one. I was intrigued by the comparisons with the Python stuff, but I know I'm a little bit all over the map, but we definitely want the plain text. So if adding that third column breaks plain text, then I think we just have to back away from it and say, you know what, this is adequate, because what you really need here is start at the top level. Does this look okay? Is when you look at this, is it not wasting too much space? Does it have the basics of what you need? And the basics of what you need are table of contents, search, and optionally that other thing someone mentioned, which is most frequently used things. Don't confuse that with table of contents. It's not a replacement for it. It would be an additional thing in addition to search, table of contents, and then maybe most recently used. But the way you find stuff in a hierarchy as a human is you use the hierarchy for the table of contents to find organized stuff that you can read through. You use search to find stuff that you're not quite sure what you're looking for, but search will miss things. And then you have something that doesn't waste too much white space as your documentation. This structure meets pretty much all of that. So I think my feedback is fine. You're fine. Go from there. From there, drilling down a level, people are kind of mixing this up. Now we worry about content. Well, that's easy. That's just submitting patches to reorganize what you have here. If you want to, and we can do that continually. If you think this isn't organized quite right, you just submit a patch and it changes a few text files and bam, it's reorganized and you're fine. You're looking good.
Yeah, we can do that.
Yeah, and I have one more thing, which is there's continual confusion, valid confusion about whether who this documentation is for. And there's obviously two main groups. There's kernel developers, and then there's people who are not kernel developers. They're either trying to test it or they're trying to use it or call into it or understand it. We could do a better job at clarifying that. That's what the third column Liam was proposing, was basically splitting out entirely. You don't have to do that. You could just make it a separate table of contents section. But if we promoted that concept all the way up to that left column, that would help, because then you go kernel developers, everybody else, and then everyone knows where to go, and there's no more of this confusion of who you're writing the documentation for. That's
Yes. There is a guide to writing kernel documentation. Yes. Yes, it does, and tries to direct people towards our related goals, such as minimal markdown or markup of the text and that sort of stuff.
And one of the reasons we have the goal of the plain text is that, again, there's two key, very distinct groups of people that are using this documentation. And one of them is the kernel developers. And those folks spend most of the time in the code, and the code has the source code tree has a subdirectory called capital documentation. So they can just, without changing their environment, they can open that up in their text editor and they're there and they get what they need, they get out, and they're done. They don't generally go all the way to an HTML page unless they're on Google and they couldn't find it anywhere else and they somehow got back to their own source code.
Well, yeah, so I think, like I say, you're organizing now a bit more by personas, and I think the main message you were giving was we have to have the personas clearer of who we're aiming each of the parts of documentation for. And I'm completely in line with that.
Well, me too. Me too. That's been the goal for quite a while. It's a long process to get there. Kernel developers like to put all of their documentation in one file. So, here's the API for your IOCL calls, and here's how it works internally, and here's how you build it, and all that stuff, all in one file. And it's been really hard to convince them to separate that out.
So usually the way I work is I have this open on one screen and my code open on another screen, and then I have like tabs also to other versions of the kernel open in like Free Electron or something that scan the source that I can search. So that, like, my use case is like I need to see this, and I have another actually it's a whole other computer with code on it. And then like multiple tabs looking at more source code. So when I go to this, it would be beneficial if I didn't have to go to another site to get even to an index copy of the kernel. So like if there was like linkage between, here's the, I don't know, I'm looking at this driver interface and it's like, well, okay, this document seems okay, but what does the code say in this particular version for this particular bug that I'm working on? And so I can click and go to another site that has that, so I don't have to git stash, git pull, get the right version, and then find out that actually it was this other slightly different version or whatever. So it would be beneficial to not only have a developer section that has the documentation, but also the ability to get to the code for that particular section from the docs.
Okay, I hadn't thought about that. That's probably doable. I mean, somebody's going to need to stand up an Elixir instance somewhere or something like that to do it, but it should be doable, and I can see how that would be useful, yes. All right, well, if we've kind of run that into the ground, I'll move on from there. I mean, this is really kind of the same questions we've been talking about how we continue to improve the structure of it and fill in the gaps that we have. Because as I've heard people say, we have a lot of tribal knowledge in this community, a lot of knowledge that's in people's heads that has not been set down in documentation. And as these people, eventually decide that maybe they don't want to spend all their time on Linux kernel reviewing patches, we need to transfer that knowledge. We need to take it down. So I don't really know how we do this. At LSM earlier this year, the idea was raised that if you put in a structure, a documentation structure with the gaps in it, that will motivate people to fill those gaps. And, because all they have to do is kind of fill in the blanks saying, write the description here. So this happened and that Willie promptly ran out and put together a nice structure for the memory management documentation like that sort of thing. So I went to see where things are and my kernel looked and just sort of clicked on one and that's kind of what all those gaps still look like. So it hasn't yet started to happen, but maybe this kind of magic takes a little time. But if we have any thoughts on how we can get people to fill that stuff in, Shua?
So I would say the tribal knowledge, transferring that is very important. And as I mentor, I'm mentoring 19 people right now this fall. So when I go and see where can I point the documentation, I struggle finding places where to say, hey, where can you learn? When they ask, where can we learn about memory management, for example? It is hard for me to go and point out. And then I keep saying, well, code is the same thing we say, code is our documentation. And it would be easier if we were to have some documentation also for new developers, new people, not kernel insiders. A lot of our documentation tends to be somewhat focused on expert level documentation, a lot of it. So you have to have a lot of know-how to even understand some of our documentation. So I think that is important as well.
Yeah, I agree. We have some pretty good process level documentation for new developers, but not technical.
Maybe to what Shua said, you say you mentor a lot of people, and I agree that newbie documentation isn't really where it should be, but when those newbies learn about those things, could they maybe submit patches to the documentation? Because they are the ones to properly understand what is missing. They can fill in the gaps that other newbies might be missing that are not obvious to people who are embedded in the kernel process a lot.
So we have a bug tracker that I don't think very many people look at.
Yeah.
Would there be like a way we could make bugs for like things that need documented and
So let me comment on what Veronica just said. I have experimented with that, having mentees do documentation. What happens with that approach is, it is a great thought, right? Initially, it appears. For other than the some of the not so complex patches, it becomes harder for them to document, because it almost feels like you need to have a little more in-depth knowledge to document. So what happens is the hand-holding process that we have to get the patches in a way we want them, the content and everything, it takes a lot more work, definitely. So I do ask the mentees to use documentation as a means to learn how to learn the process of submitting patches. And some of them graduate. One of my mentees went and did last spring. He figured out there was white space in Japanese version, and he submitted a bunch of patches. He actually cleaned up a lot of the Japanese. So some of them do that. But in some cases, that becomes, and there is a bug. So yes, I think it would be a good idea if we have a to-do type of thing to have documentation needs. So create, and then we can use that and then have a new developers pick from that. So.
Yeah, I don't think you need like the to-do. Somebody could take something off that, and they don't necessarily need to be the expert. You just need somebody to drive the process, I think.
Right. Well, so some of the sections have a lot of subtleties in it. And what I'm kind of thinking is we try to get the ELISA architecture team, as they are analyzing parts of the kernel and the implications and how things work, and ask them to fill in the gaps, as would be a group that has motivation to really provide that type of information because they need it for themselves. Now, the challenge is keeping it up to date as parts of the kernel change.
Mm-hmm.
And so the question is, if they put something in for a subsection after they've done the analysis, can we count on the maintainers to review it for accuracy? And then no, like I say, can we make this a positive experience for multiple people here and get useful results out?
Can we have doc tests?
I mean, some maintainers will do that, others will not. It's all variable. But I would say, just to say, continue. Yeah, some people can show the pattern properly. That would help. I would just add to on this theme that one of the best ways to really learn about how something works is to make yourself explain it to others. Right. Having made a living this way for decades, I understand this very well.
Yeah. So one of the things that I found was on my team, I recently had to bring 2 new employees up to speed on ext4 development, and GCE XFS test is actually one of the primary ways that we do test-driven development. And having someone new, that sort of beginner's mind, was really, really helpful in finding out where the gaps were. So I asked both of them to give me notes about what they were confused about, or when they asked me questions, I made notes. And then we fix the documentation. And so that may be an approach where if you're working at a company and over the period of 9 months, I think this takes longer than a Google Summer of Code type experience, you're bringing a new MM developer up to speed, have them take notes about what they needed to ask, and then use that to drive the documentation. I think that's probably going to be one of the best ways to do that. And then as a bonus, maybe that new developer also gets introduced into upstream development.
So one thing we have for KUnit, and this probably works a little better for a tool than a general subsystem, is the first section of the documentation is a getting started guide. And maybe if we can have for more subsystems, the first section of their documentation be getting started with this subsystem. Doesn't have to teach you everything or how every little bit works, but here's at least an entry point. I mean, requiring that just creates a whole new bunch of gaps to fill, but it could be an interesting way of providing that entry point.
Another thing we could do here is when you get an empty topic, if we have some files that are tagged against it, could we have a bot pick up the last few, or even just generate it from Git, the commit logs, and just put the one-liners in here with a link to the Git commit logs, so at least you have a starting point of, hey, there's actually something here I can read through. Maybe it doesn't explain how virtual contiguous memory allocation works, but these were the last few bugs that were fixed, or this is the last feature that went in. And then people will say, hey, there's Git logs for this stuff too that I could maybe leverage to figure out how this insanely complicated system works.
That might work at something like a driver level. I think it's gonna be really hard to log every memory management change. And
Sorry. Yeah, I don't mean every one. I mean, like, just have a running thing of the last 10 or 15 or something, right? I mean, and that would probably also help for how did this change last since I was here? And you're like, oh, there I am on the 5th one down, and these are the 4 things that happened.
I just want to provide a counterpoint view, which is that I caution strongly against trying to auto-generate documentation. Documentation is hard. You'll find that when you go to create documentation, only about 1 out of 10 of your developers will succeed in creating documentation that's durable and generally useful. Everyone can create content and ideas, like Ted was saying. It's fantastic. You know, I always make the new folks go in and correct the documentation and tell me, like you said, ideas for new docs. But actually writing a paragraph or 2 up here that doesn't turn into 6 pages of noise or a few paragraphs of unreadable stuff, that's actually hard. It's a human activity. If you try to auto-generate it, you will hurt yourself, and you'll generate a lot of white space, a lot of noise, a lot of things that should be in other systems like Git. So my feedback is never do that. So.
Well, hold on now. I don't mean generate the text. I'm actually saying link to the Git ID, like just one-liner, and then you click on that and it brings you to the code. And if your developers aren't writing decent Git commit logs, then that's another problem, right? And I feel like there should be some explanation as to how at least their fix to the code went in. Or why, yeah.
On that, I think what we really need an accessible thing is the mapping between this file of code, this file of documentation, because that's not obvious. You know, the code might be in some random directory, the documentation tree is organized differently, particularly if we're reorganizing documentation. That mapping needs to be somewhere. And it might not be perfect, but something should exist.
I have a feeling that you are losing context. Why do you actually need documentation? Because once you start to document files, specific files, and explain it, it is unclear to me, at least for the kernel developer, to whom you are going to, who will read it. I would like to see in documentation general concept, something that is not going to change. I don't want to see Git log because I have Git. I don't want to see Git commit because I have Git. I know how to compare different folders and different revisions. Really, it's not something what at least kernel developer would be happy to see in virtual contiguous memory allocation section.
Okay, so the person who wants to look at the documentation and understand what's going on is someone who's basically working using Linux inside some of the SpaceX and things going that are mission critical, that they need to understand a whole system and Linux as part of a system so they can do the right safety analysis so that people don't die. Those are the people that care about this stuff.
I will give you an example for my experience, which I had, I think, 5 years ago or maybe more, when I was working on memory hot plug. In general, if you're looking at the code, it is to some extent self-explaining. But when I went deeper and deeper, it was much more difficult to understand what is going on. At some point, even I was not able to understand why these, for example, variables get these values or something like that. So I think that somebody who designed, for example, memory hot plug should explain clearly why this was done in that way or something like that. So I think that this documentation is for new developers, mostly, who are looking at the new code. This is important, I think. This is
So basically, the documentation is not for the kernel developer experts, because if you are expert, then you already know those things. You don't need the documentation. It's for everybody else who doesn't belong in the.
I would disagree with that, yeah.
So we only have about 10 minutes left of this session, and I suggest that everyone goes and reviews the matrix chat from the last half hour, because we actually have experts in documentation who are getting annoyed at you. Those of you who are those of you who are pointing out problems, absolutely. Those of you who are suggesting solutions, you perhaps don't know as much as you think you do. Zusa in particular has some excellent critiques of some of the solutions being proposed here. I don't know if Zusa is going to join herself, but she has some suggestions that we make it more possible for people like her, who are documentation experts, to contribute, and maybe they're not particularly comfortable sending patches, perhaps they're not particularly comfortable with our workflow, but this is an area that has expertise, and we are not availing ourselves of it. Speaking for myself, I've tried to get companies to pay tech writers to help out with this, and I've never been successful. She suggests that we use Google Summer of Documentation. We should also listen to people who are new. Nur Hussain has been making comments about how he's been trying to, I think Nur is a he, anyway. Nur has been suggesting how new developers get up to speed, and it's all, oh yes, take a look at this book from 15 years ago, and then work through the Git history from there. I mean, the frustrating thing is I can't argue with that, right? I mean, you know, I was the one who created this completely empty page in the hope that somebody would come along and fill it in. Oh goodness, I've forgotten half the things I was going to say from the chat. I do suggest people go back through the matrix and read it, because there were some really good suggestions there, and there just wasn't time to fill it all in. One thing is that Zusa suggests that we move on from RST. I know when you just got done converting to RST. Her preference is for ASCII doc. I don't think we really want to get into that kind of fight right now, but at least from RST, there are tools we can use to convert to other formats. Speaking for myself, I really wish we could get away from the kernel doc style, but I mean, you've heard that rant from me before, John, you won't hear it again. I think that's all I need to summarize from the chat, but I didn't want to run out of time before the people on the chat had the chance to say something through me.
Right. Yeah, that's fine. I mean,
you have about 5 minutes, so
okay.
I don't know if you want to summarize.
Yeah, I'm not. That's going to be hard to summarize. I got through about half my slides, but that's fine. That's we'll just forget the rest of them. Yeah, I'm not entirely sure what to take away from this, other than that we would all like to have better documentation. And we've talked a lot about structure and organization, and haven't really cracked the problem of how all this documentation is going to get written. I mean, if we fill in all these gaps, I mean, somebody's written a textbook if we've done this. This is not a small job. And I'm not quite sure how we're going to get that done.
There are textbooks out there. Can we approach the authors to help us, for one thing? But then, should we keep the conversation going so we just don't talk about it once a year? Can we have some sort of forum where we can, people who really care passionately about this and the tech writers who care about this can show up and participate?
There is the Linux doc list, of course.
Yeah, but I'm thinking that is the structure of an email list. Some people want to talk these things through in meetings. Sorry, but that's another style of cognitive evolution that people.
I mean, we could perhaps organize an occasional meeting, yeah.
Okay. I'm volunteering to help organize a meeting, if that is a help.
We all love more meetings.
I know.
All right. Yeah, I mean, there's no point in trying to go on to the other topics I had, so we'll run out of it. So I think I'll just wind down here. And I thank you all. I'm glad that people are interested in this. I hope that we can take some of this interest in and push it into actual action on the documentation. Thanks.
Okay, everyone, let's get started with the second session. This is a talk on Rust, or specifically Rust in the Linux kernel, by Miguel and Wedson. Thanks, guys. Take it away.
Thank you. So this will be a discussion talk, basically. We hope we have a productive discussion. So we will show some topics. The first few topics are things that we think are very important to discuss, and we should really discuss them today. We also have some additional topics in case we need more and you want to continue discussing. So the first one is that in the last patch series that we sent, we trimmed down as you know, the V8, which contained the full set of changes that we have produced over the last months, into a V9 that is basically very small. Concerning the kernel crate, which is the crate that contains all the Rust abstractions, the code that goes into the C APIs, the code that wraps the C APIs into safe abstractions. That is basically what the kernel crate is all about. And we reduce that from what we have in V8 into, I think it's about 3% of the code. So yeah, it's a fairly minimal set of changes. It could be made more minimal even, but yeah, that's V9. So the first thing we would like to discuss with you is there anything else that you would like to see in that past series, or V9 is good for you? You think it should be more minimal, less, etc.? Oh, yeah. If nobody says anything, it will be, yeah. Go ahead.
Yeah. So over the past almost 2 years, what we've been doing is working on adding support to the build system, and also adding abstractions for some subsystems, and writing example drivers and just samples in general. So what we did in the latest version of the patch set is reduce it. And so most of these subsystems are now out of this patch set. And part of the reason we want to start upstreaming and pushing these things is to make it easier to review, because part of the feedback we got was that the patch series was too big now, right? But it is too big because we've spent all this time adding new things to it to try to demonstrate how one would go about writing certain types of drivers in Rust. So what we're trying to get from this question is mostly like, now that we have this minimal thing, is there anything else you feel that we should do, or would be interesting to
make the merge happen, basically?
Yeah, to merge it.
Like if somebody thinks there should be some abstraction that should be there because it's the core, or if somebody thinks the build system needs something else that we need to add, anything really.
Okay, let's go to the next one then.
Yeah.
we have lots of things.
Yeah, we have lots of things. So assuming that that V9 gets merged, or a V10 or a V11, it's something like that, a minimal series is merged. But you cannot read the full question, but yeah, what is the expected path for the remaining parts? So the 97% of the things that we didn't submit on the kernel crate, mainly, the 97%, through which trees we should submit it. Because, for example, we have abstractions that Wedson and other contributors wrote that are for a particular subsystem, right? And we would like that maintainers of that subsystem, the experts on that code on the C side, review the Rust code as well, which I think would be, we think it would be the best if we could get the maintainers to review it. So should we submit that code through their tree, or we should put everything into the Rust tree? Basically, we are happy with both options, I think. Both are reasonable. especially in the beginning, right? In the beginning, since we mostly grow the code.
I guess I would offer some experience based on the documentation tree, which tends to cut across all of the kernel, as you will eventually do. And what you're going to find is some maintainers want to carry stuff themselves. Some will want you to do it. You'll always get it wrong, and you really just have to learn it on a case-by-case basis.
Okay. Yeah, that's
fair.
Fair enough. Yeah.
Fair enough.
I think it will be, speaking purely for myself, I'm not relaying for the chat here. I would want to, as a maintainer, I would want to be submitting the Rust code myself through my tree for a few reasons. One is that I don't actually know any Rust. I'm just really enthusiastic about Rust right now. I don't know any, and obviously I'm going to need to know it. I'm going to need to learn it. That is going to be part of a maintainer's job, because the kernel is getting chunks of Rust in it. And if I'm maintaining a subsystem, I'm going to need to know Rust. And so I may as well learn it by reviewing code that other people have written in Rust and think is now ready to be sent upstream. And I mean, you guys are the Rust experts. If you've written it, I'm sure the Rust parts of it are good. What might not be good is what it thinks about the C parts of my subsystem. But that's the area in which I'm an expert. So, you know, I want to control which bits of Rust that pertain to my subsystem go into the tree. So that's one thing. The other thing is that you don't know my subsystem. Maybe my subsystem's going through some changes, and perhaps you've wrapped the old API, and I'm trying to move everyone over to the new API. We would just never want to expose that old API to Rust drivers ever. So, you know, you may have made a strategic error that you couldn't possibly have known about because I hadn't told you. So, I want to see it.
Yeah.
But maybe not everyone's going to feel that way.
Yeah, so again, speaking for myself, one quick observation I would make is it's a good idea not to assume that all kernel subsystems maintainers have been following V1 through V8 of your previous patches. They may or may not have even remembered your previous Rust talks at previous LPCs. And so having some web page that you could point people at that, you know, has a collection of, you know, slide decks and code tutorials and easy steps, because I suspect you will find different kernel developers will be in different places. Different maintainers will definitely be in different places. And, you know, you're going to have to meet them wherever they are. And this really goes back to some of the documentation discussion that we had at the previous forum. Don't assume that all the kernel developers are experts in areas outside their subsystem, because they probably aren't. Many of us really do have to specialize just because we don't have enough hours in the day.
Right. Thanks.
And to echo something that John said, like, you're definitely going to get different responses from different subsystems, and yeah, you'll probably get it wrong, and that's usually, like, if you go through the wrong tree by accident, that tends to be, generally speaking, a more forgivable mistake. The bigger deal is, like, make sure you get that subsystem's maintainer's ACK. And then, you know, sometimes they'll say ACK and take it through my tree, ACK to go ahead and take it through your tree. The thing that people tend to be a lot less forgiving about is, why didn't this have my subsystem's ACK when you're binding to my subsystem? So I would worry more about that one than which tree it happens to go through. That'll, you know, that'll fall out of things eventually.
Yeah, we have tried. Sorry.
Plus one on what John said. I maintain K-self-testing, and I have similar situation of tests and API going together through other trees, and so something to watch out for. And same thing with the axe. Sometimes, you know, after a while, early on you might be looking for axe and such, and after a while you might get into a informal arrangement with the other maintainers. So things might be, there will be some kind of arrangement, but there will be, you're always going to be running into these things, especially if you're working in an area that cuts across all the subsystems. So be patient with that process. And then some maintainers don't like patches going through other trees. So you kind of have to maybe have one-on-one conversation with them and say, hey, it's not like, what you're doing, trying to see why you want to take something through your tree for maybe good reasons at sometimes, and you have to kind of work with that process. So be patient with the process.
Oh yeah, we try.
Yeah, we even back to the Josh also point there. Whatever the tree is, for sure, we should be CCing everybody that is involved. That's for sure. Yeah, the question here is not about trying at all to bypass anybody. Quite the opposite. It's about whether if some maintainers would like to have their tree take the patches, it will be even better for us. Especially regarding the next question, which is related, which is the maintainership of that. So of the Rust abstraction. So if we have we have started writing abstractions for some subsystems, especially Weston, Andreas, and others. Ideally, let's say, or at least medium long term, but as soon as possible on our side, we would like that. The subsystem maintainers, the experts on that subsystem, maintain the code, that they take ownership of the code. So I think the first step to that is getting the patches accepted through the tree to begin with. And then we are happy to help them. We are happy to,
So we've built a number of abstractions. So the first thing that we need is for the maintainers to review them, of course, because as we all know, the maintainers are the experts and they are the ones who know what needs to go in and should go in. And we are also, as Miguel was saying, happy to work with other maintainers in building these abstractions for their subsystems whenever they decide to do it. But we'd like to see that they will maintain it once it goes up.
Yeah, just from the graphics subsystem, I'm kind of hoping we get it driven from a slightly different direction. I'm hoping that we've had one person who's interested in starting a graphics driver using Rust, and we're encouraging that, but we're hoping that they can drive it into the subsystem as well. There's not so much you guys have to do that work, that you advise them, they become the sort of subsystem expert as well with your help, and then they put their driver in and it just comes through the tree naturally. We don't have to, there'll be a bit of, I'm sure there'll be glue and stuff we have to deal with, but I'd like to, if most subsystems can actually, I don't think you need to drive it into the subsystem from this side. It should come from drivers wanting to use it into the subsystem and having that develop in the subsystem itself. It may be a better way to, because then you have a Rust expert here that's in the subsystem and you've got Rust experts over here and you can, come at it from both sides. So it may be a bit of a different dynamic when we actually start merging this driver, looking into merging drivers and stuff.
Yeah, that's fair. One thing we'd like to say is that we're available. Like if let's say somebody wants to write a driver for some subsystem, right? And then maybe that subsystem maintainer doesn't like the idea of having Rust there, right? We're saying that we're available to help and discuss and do these things.
In fact, we got approached by a couple of companies or people, let's say, about, hey, I want to start using Rust. How do I do that for my subsystem, right? And the answer is, please go ahead. We can help, but if you like to even take maintainership of it from the beginning, that's even better for us.
Yeah, this is not necessarily going to be a sustainable approach indefinitely, but at least for now, as long as you continue to have the bandwidth to review and help with Rust code everywhere in the tree, I'm hoping the maintainer's entry for Rust in the kernel literally has a star.rs in it, so that literally any Rust code going through the kernel gets CC'd, so that you could at least have the opportunity to look over it and say hey, since we're all still learning Rust in the kernel, then here's some patterns that might have made this code a little bit better, that kind of a thing. That might not scale forever, but hey, let's do things that don't scale as long as we don't have as much code in the kernel.
Yeah, it will be hard for us to monitor everything, right, and review everything.
Right.
But sure.
Already the things we are getting in the repository we have, where we put everything. So the patch series that we sent is basically a subset of everything, that other things that are pending, that we have pull requests by different people that are submitting things, but we didn't have the chance or the expertise so far to review everything. So there is already things that are coming, and it's a lot of things that are coming.
So you may not necessarily be reviewing like the kernel content of all of those patches, but like there are a lot of addresses and similar that get CC'd in the kernel where they're just doing scoped review on certain things. Like you CC Linux API if you're adding new API surface anywhere in the kernel, and it doesn't mean they're reviewing the subsystem specific bits of that. But like, even if we need to make a second list for Rust in the kernel, like here's the fire hose list that gets copied on every Rust patch, at least some people may look over that and start, reviewing aspects of the Rust usage and trying to help out with that.
Yeah. It would be good if we actually had Rust developers, like developers of the compiler, also watch that list and help.
This is why I'm asking to make sure that happens. Yes.
Yeah.
I think we will have a lot of interested Rust users who would love to like take a look at that and volunteer. Like, hey, go take a look at this. You don't have to be a kernel expert. If you're a Rust expert, you may be able to help.
Yeah. In fact, we got already a few people that joined us as Rust experts and not kernel experts or developers, and they have been very, very helpful. Gary, Benno.
Yeah, they provide great feedback. Yeah, so the experience has been good there. But
John as well.
A lot of the more intricate work of exposing safe abstractions for the subsystems involves understanding the subsystems better, right? So it takes a lot of effort to review the minutia of these abstractions, right? And that's why I feel it's more like it has to be a collaboration rather than just us like looking over and then giving suggestions, right?
Absolutely.
Yeah.
Okay, we can go to other topics, additional topics. The first one that we have here, we don't need to, they are not prioritized or anything. They are topics, we have 2 slides with some topics. The first one is splitting the kernel crate. As I said, the kernel crate, for those of you that don't know, is the one that has all the Rust abstractions that we are talking about. For the moment, all of them are in that crate, which a crate in Rust is the compilation, the translation unit of the compiler, which, yeah, it works for now, but probably we want that, for example, instead of having, because also right now we have all the code in the Rust folder, the root of the repository, but probably we want to write the subsystem code and the subsystem abstractions in their own folder, just like with C. And for doing that, we will also have to manage the dependencies between the crates around the kernel. So yes, there is some work to be done there. Yeah, if somebody wants to discuss about that, yeah.
Yeah, so one thing we thought about doing for dependency is actually try to formalize these dependency graphs within the kernel. So our thought is to do something like when you define a new crate or abstractions for a given subsystem, is for you to actually specify who can use those abstractions, right? And then if somebody, if some component is added, you would have to learn about their addition and allow them to use these components that you're defining. We actually are planning to do this even when we split the kernel crate for something like there will be a crate where the C bindings are visible. We don't want those to be accessible to.
I have it here. This one. Yeah.
Yeah. So we run this tool bindgen to generate these bindings. All these calls, like calling into C, is inherently unsafe from Rust's perspective. So we don't want those to be exposed directly to leaf modules in the kernel. But we want those to be exposed, or need those to be exposed, in fact, to subsystems, because that's how the subsystems will interact with the C side, their C side. So we want to do something like there will be a module, a crate that is this bindings crate, but it's only accessible to subsystems. It's not accessible to drivers or modules in general, leaf modules. And yeah, so this is our plan, and this is mimicking some other experience we've had with other build systems, where you declare these dependencies. And this also was something that Greg brought up. In the talk we had a couple of days ago, I said we were exposing, for example, consuming file objects. So
from the kernel, you could like open a file and read and write to files. And Greg was like, oh, I don't want that to be available to drivers in general. But if you look, there are some drivers like KSMBD who actually need that functionality. So the idea would be to define a crate like this that allows you to do these sorts of things with files. But that crate would not be widely available, only on a case-by-case basis like KSMBD or the 9P server or something like that. So this is sort of the plan we have for the Rust side. Yeah, if you have feedback on that, or if you think we should look into C to do something similar, perhaps something we should look into. Yeah.
Yeah, it's that kind of improvement that there are several improvements over, during the months we have been working on the Rust side, because we had, like, let's say, a bit more freedom, or we were thinking about new things. For example, this idea about managing the dependency and the visibility between modules. Some of those things we may want to apply also to C, and could be interesting projects on their own, right? Yeah. But we want to make, as far as possible, we want to make it independent, orthogonal to the Rust effort. Yeah, the next one that we have here is toolchain requirements, defining a minimum Rust compiler version, and especially in particular when that is possible, when we don't have any more unstable features, and the cadence of upgrades of that minimum version. So as you know, for GCC, etc. Well, GCC is, I think, right now in GCC 5, the minimum version. Clang is 11, if I'm correct. Right now, we are upgrading the Rust compiler because anyhow, we need to use the unstable features. So whether we upgrade or not, it really doesn't change much. So we are upgrading until the point where we have all the unstable features covered, and we can start compiling the code with only a stable feature, which means that the Rust teams, the compiler, the language, etc., promise that there is backward compatibility, 100% backward compatibility. So the discussion here would be, or this point is about when we reach that point, how often we want to upgrade the Rust compiler. Do we want to do something as slow as GCC? As slow as upgrading GCC? Do we want something more, less years basically between the release of a compiler and the last time we support it, like in LLVM, it's less time, at least for now. So yeah, discussing a bit the cadence, if somebody has ideas about that, or do you think we should establish, for example, a minimum number of years or a fixed number of years, and then we, yeah.
I think on the toolchain version thing, and as you say, like, there's a way to go before features are stabilized and we can, continue to use the same version. But the constant upgrade of the version required is actually a bit of a pain at the moment. And perhaps something like, at the very least, you want to be able to use a compiler that is in a distro repository, not something you have to download a nightly or stable compiler from Rust up or something. And I don't think we have to go back as far as, GCC 5, but there are definitely, we have on the KUnit side some code coverage things that broke after GCC 6 that we haven't fixed yet. Certainly something like target the compiler available in Debian stable or something. That's going to be pretty horrific from a Rust point of view, where people are used to using more new things. But I think we want to, once things are stable, support relatively old compilers.
Yeah, for sure. We don't want to do it just for fun. Unless there is something coming in the Rust compiler, the Rust language, that we really, really want to use for some reason. We don't. The idea is not to upgrade just for the fun of upgrading. Yeah, that's for sure. It's about the question of whether we should establish any cadence. Like, okay, say 5 years. We wait 5 years, and then we upgrade to we establish like a 5-year delay or whatever.
Yeah, I think tying it to distro cadence is going to make a lot of sense, because the number one reason for the minimum version is going to be what's available in distros where people expect to build kernels. I think the huge open question is going to be which kinds of distros, because there's a very big difference between it's available in latest Ubuntu versus it's available in latest stable Debian versus it's available in latest stable RHEL. And that I think that's going to determine a lot about which portions of support, and that's a balance that we need to maintain. I don't think anybody thinks we're going to upgrade every 6, 12, 18 weeks, but the question is, do we upgrade every 2 years, every 3 years, every 5 years, every 10 years? And I think that there is a lot of hope that it isn't necessarily on the 5 or 10 end.
Exactly.
We hope, yeah.
Can you hear me? Okay. We have quite similar problem in the Grab project, and we are discussing this. My opinion at this point is that we should only upgrade when we need new features from the compiler. So we support the lowest minimal version, which provides us recurrent features. And if at some point we think that we need a feature from the newer compiler, then we bump the recurrent version for the compiler. I'm not sure that this is the best approach, but I think that it is most convenient at this point, I think.
That would be similar to the GCC approach, right?
Yeah.
Where we upgrade when we really want something new.
Somebody back.
The other thing we do for some things in the kernel is we gate the if there's a particular kernel feature which needs a new compiler feature, we gate the kernel feature on that compiler feature being available. So there are some things that have way newer minimum toolchain versions than GCC 5 or whatever. And depending on why somebody wants to use a new version of Rust, that might be a viable approach as well.
That's going to be especially true for things like security features and architecture support and similar. Like, yeah, if you want to turn on security features, you need a compiler that has support for those security features. And if you want to build your entire kernel guaranteeing that every line of code had that feature, you do have to depend on a compiler that has that feature. I think that's the kind of thing that makes people not want to wait 5 years.
One sort of meta comment here is, and again, this goes to don't assume all kernel developers understand what's going on with Rust. Part of, in terms of the whole, should we be targeting Debian stable versus RHEL versus Ubuntu stable versus, bleeding edge Fedora, I don't know how to make that engineering trade-off because I don't know what Rust features are available and what timescales and why we might need them, right? And similarly, when you were talking about splitting the kernel crate and how do we hide certain abstractions from certain modules, I don't know what's possible, right? And it may very well be that one of the things you can do that will help is to provide a menu of options to kernel developers so they can understand, how painful is it, for example, to move functions around between different crates? How can we make it so that you have to go through a bit more effort if you want to use some of these unsafe bindings? And there may be, on a case-by-case basis, a reason why a device driver needs to do that, but maybe it triggers higher level review or something, right? I don't know what mechanisms are available. And so therefore, when you ask me these questions, my first answer is, I don't know. You need to give me some trade-offs, and then we can evaluate the trade-offs across, what we believe our development requirements are, right? And I think it'll take a while before we can actually get to the point where we're going to be able to have these conversations very easily, because I suspect many of us are missing, I know I am certainly missing much of the necessary background.
Yeah, that's very fair, yeah.
Yeah, some of the things we talked about before, we gave a little bit more detail in the session we had a couple of days ago, and here, yeah, we're very slim on details because we thought the intention was just to have the discussion,
or at least to raise the point for future discussion, etc.
Hi, I've had some mixed experiences with bisecting and the Rust compiler, where when you try and build something that's old with today's compiler decides, no, what that old code was is unsafe, it's changed its mind and it won't compile anymore. Do we foresee these sort of problems, and what sort of guarantees will we have about bisectability?
We actually have an item about bisection on the next slide.
It's slightly different, but
slightly different, but a problem with bisection. Yeah, so, but let's try to. So
Yeah,
there's that may be a problem, but that wouldn't be specific to Rust, right? Like one thing that Rust has to help with that is additions, right? You can say things like, I want to compile with the 2018 edition or some other edition, one of the things we do in the makefiles and the infrastructure to build things is we specify what the requirements are in terms of addition and things like those. So we hope that there will be some, this will help a bit, right? Maybe not solve all the problems about the safety and things like that.
If there is a bug, also another point is that if there is a bug in the compiler where the borrow checker, for example, is not catching something, and I would expect or I would hope that if we are supporting that compiler version for Rust, the Rust upstream would provide a 0.1 release of the compiler. They do sometimes when they find this kind of, right, Josh probably knows, can answer much better than me. But basically, I would expect that if a given Rust C version is very popular to compile a kernel, then, and they found a bug, a really critical bug there, so that I would expect or I would hope that the Rust teams give us a 0.1 release of that compiler fixing that particular bug.
Yeah.
Right?
To add to that as well, like you mentioned having issues with particular types of code, I think this is absolutely something that will get substantially better when we get to the point where we compile with 100% stable Rust. Like the kernel is currently experiencing a flavor of Rust that is not what the vast majority of Rust users do because it's using so many nightly features that it has to in order to prototype and work at all. The concept of like, I used a newer compiler and now my code doesn't compile is something that never happens in stable Rust by definition, that like we do not break existing stable code. And once you're on 100% stable, I expect we're going to start including kernel trees in the system we use called Crater that tests every piece of Rust code that's public and that we're aware of, so that every single new release of the compiler will have test runs that compiles tens of thousands, hundreds of thousands of projects, including the kernel, and verifies, yep, still works all the way back to every version that's been used. It would not be hard to add not just latest kernel, but like last 30 releases of the kernel into Crater, for example. And I would expect us to do that.
And then when they do have breaking changes, then it's a new edition. Right, and that's the thing where you'll say like I'll use some previous edition, and then the expectation is that everything will just work.
Right, exactly. You have to opt into I want the behavior of the language to change, and if you don't, then your code keeps working forever.
Yeah, the editions for those that don't know, back to the Ted's comment about the context, the editions are basically like the C standard versions, let's say, or releases. Right?
One thing that's kind of coming up is. Is the kernel going to be a hermetic build, or are we vendoring crates or constructing our own versions of well-known crates, or are we going to be using Rust up in? Oh, I'm sorry, I didn't look at the next slide.
Yeah.
It seems like a good point.
Yeah, no, it's completely fine. Yeah, go ahead, please. So, for example, so let me give very a quick, so what we vendor right now is vendor, really. So there is the core crate, which comes from the standard library of Rust, that we pick from the compiler itself, so it's the right version. It's the version that the compiler needs, basically. So that is tied to the compiler, so to speak. Alloc is the library that handles, contains some data structures that need allocations. And we are vendoring, or we are copying basically a subset of the alloc crate, because we don't need, first of all, we don't need all of it, but most importantly, because we needed some extra things. So we are doing that, but for the moment it's just that. We are not taking other, we don't do vendoring of third-party crates, let's say. There is a point here in this slide, which is, should we allow or should we try to reuse code that people has written in the Rust community? There is a lot of useful crates that we have some contributors that told us like, oh, really, I want to use that crate, or I want to use this other crate, because maybe they come from user space Rust and they know and they use those crates, and they are useful because they are no STD crates, which means they are crates that don't require the standard library. They can be used in an embedded context, let's say, and that code can be reused up to some degree. I mean, you cannot reuse everything. Sometimes maybe you need to do adjustments. It's a case by case. Has to be case by case analyzed. But yeah.
So in user space, people are used to using third-party crates, and it's very easy for you to automatically download and build those things in the user space. We don't support that at the moment in the kernel, but we've received requests from people to do something like that, and this is one of the topics we'd like to discuss here. We actually have some kernel people asking for this and pushing for this, and some people are just against it altogether.
This is a little bit of our perspective. We started using Rust in the Mesa project, the graphics driver user space project. We've put a hard no on using crates at runtime because when you go to distros, they want to build offline space. So we just said no, but we haven't decided, I don't think, on whether we're going to vendor in crates, but I don't think we're against that. But we're definitely went hard no on the runtime bringing crates in.
Yeah, so our decision had been a hard no too, and this is where we are at the moment. But we're getting people asking for this and pushing hard for this, right? That's why we sort of brought this up as a point for discussion here. We want to hear from you guys. How do you feel? Should we try to support it or just...
Yeah, we are trying to, before we, since the beginning, more than 1 year ago or 2 years ago, we tried to be as close to the seaside as possible and not do anything that was not really needed. So that's where we are in most of our decisions. But now is the time where maybe we need to start asking, like, do we need this? We could do something better.
I'd say stick with that hard no. If you've ever looked at, for example, the FreeBSD kernel tree, they've got all sorts of other projects in there that they link in, because if you compile some C files into an object, then you can link against it, and it's a static object. It works, but it introduces a lot of lack of uniformity. And kernel code now, it's not completely uniform, lots of different coding styles, etc. But at least there's some uniformity, and this allows some latitude in doing things in particular kernel ways that are optimized for how the kernel works. Things like RCU patterns being everywhere. And because Rust as an ecosystem and a movement is so much larger than the kernel itself, or so much more diverse, I should say. Sure, you have a lot of user space programmers who want to use these crates again, but there might be a certain value in them maybe not being able to do that so easily, having to learn about the differences of kernel development, that you can't just take some user space code, or if you intend to do that, you have to really take it apart and understand how it can function in the kernel context.
Yeah, it's clear that we can take arbitrary crates at the moment, right? For example, most of them, at least the ones that I looked at, for something else, they all, for example, assume that if you allocate memory and you have no memory, then it's okay to panic, right? It's not something that would be acceptable. So yeah, definitely.
There are others like proc macros in Rust, which are like compiler plugins for code generation. Okay, those really run on the host. They don't run in the final kernel limits. They are just compiler plugins. So those kind of stuff are, some of them can be really useful for the kernel, and they don't end on the kernel limits. So some of those are also one candidate, the first candidates that we were considering, basically. They have nothing to do with the kernel. It's just facilities to use easily the language.
I think there's a lot of value in supporting vendoring of third-party crates insofar as you have to actually drop them into the kernel tree and they need to go through review. If you actually want to add them, they'd be part of a patch in a tree. They'd go through a review process, and that would provide much better opportunity. As much as people are going to push for it, I genuinely do not think you should even have experimental support for pull it straight from the network. There are standard tools for grab it from the network and drop it into this directory. Cargo vendor is really trivial to run. Like, add support for using stuff in a vendor directory, and if people can't go to the trouble of dropping something in there and they really want to get it straight from the network, that seems like too little friction, and there would be no vetting of that code.
So a comment from because I work on Rust 2 RPM and Rust packaging in Fedora. It's really no biggie to have dependencies on crates, and it's in general much more preferable to have to depend on crates, which are packaged as distro packages, than to have vendored code. I mean, there might be good reasons to vendor code, but distro builds is not one of those reasons, certainly.
Josh?
Say something.
I mean, before my comment was just talking about importing third-party code, but I mean, if we're talking about crates going through cargo and pulling these down off the network, you got to consider the dependency trees and the general impossibility of auditing this code and understanding massive trees that sometimes come down when you pull in a crate. I mean, if we open that box, you know, say only no STD crates because nothing else will work, or only certain well-behaved ones, we're still going to have trees of dependencies coming off of this, and the whole thing becomes then hard to manage. Even if we vendor those, then it's in some vendor directory, which begs the question: well, if we have some new interesting library code, why isn't this in /lib? Or I mean, why can't we take the bits of Rust that we want from elsewhere that are useful? Other people than the kernel write useful algorithms, of course. Why can't we pull these in and put them someplace that makes sense organizationally, rather than just here's a massive tree of dependencies in some vendor directory?
Yeah, we are actually with you. So we'd actually like your help. When people come asking for us, we'll redirect them to you to help us convince them that this is not a good idea. They're very pushy.
So I don't think anybody is going to want to drop like 50 crates in a dependency tree directly into a vendor directory. I think that would be an incredibly bad idea. I think, on the other hand, the kernel today currently vendors a few bits of C code from well-known places. For example, there's more or less a vendored copy of libzstandard in the kernel in order to do Z-standard compression, and libzstandard upstream did a bunch of work to make sure that the code could more or less be dropped verbatim into the kernel. That's the standard I would expect vendored crates to be held to, is we can use this unmodified and there's no issue with it. And short of that, like, the reason I'm suggesting that it is actually valuable to do it as a unit is for exactly the thing that somebody from over on that side of the room mentioned, of that distros want to be able to extract that vendored code and say, we don't actually want the bit from the vendor directory. We want to use the bit that we've packaged in our distribution. And if you know it's unmodified, then you can very easily factor it out and share that code and not get it from the vendor directory and just say, well, it's the same as the copy we already have in our distro.
Yeah. It may very well be that what we're doing is we're bridging cultural differences between, say, user space Rust developers. And it may be helpful to have some documentation that explains the requirements, right? Because otherwise it will feel like we're making arbitrary restrictions. And so explaining to people, for example, that it is an absolute requirement for some release environments that you be able to do a build without access to the external network, right? Explain to people that we want a specific kernel commit ID to absolutely reflect, the same set of bits, right? We need reproducible builds, and so that means for bisectability purposes, we don't want to like randomly drag in the latest version of some Rust crate that changes how that would have behaved when it was built 2 years ago, right? And I think if we sort of explain it in terms of requirements, then it will be a little bit easier for people to understand why things are the way they are. The other thing about the vendor directory is if somebody pulls in something, they just do cargo vendor, whatever, and it results in a kernel patch, which is 3,000 lines of code because they just pulled in a dozen different crates. When that goes through the review process, a kernel maintainer will probably say, hard no, I can't review this 50,000 line thing because there's all this magic code that just appeared. We aren't quite as trusting as some other people are.
Well, there's 1 minute left. Do you want to summarize, guys?
Yeah, that we welcome any help on all these decision points. We are trying to do what is best for the kernel. We don't have any hard, we welcome all these. We are just asking because yeah, we want to hear your opinion and do what the kernel community thinks is the best way to go forward. And thank you everyone for
Thanks,
coming
everybody.
and listening.
We now have a half-hour break. See you back here at 5 o'clock for my talk.
Hello again. Next up is Matt Wilcox talking about Zeta Linux.
Thanks, everyone. Hi. So the obvious question is, what on earth is Zeta Linux, and why is it not too late to start? So Zeta Linux is simply a term I made up. I'm kind of riffing on the whole exascale thing that the US government is talking about right now, where they're trying to get to 2 to the 60 levels of performance. And so the question is, what comes after that? Well, if you look at the alphabet, exa comes before zeta. So I'm looking at what happens when we run out of 64-bit. When is 64-bit not good enough for computing? And a lot of people are going to say, oh, come on, that's going to be years away. And the answer is actually, well, yes, it is, but there's good reasons to start now, because we don't want to get caught wishing we'd started earlier. So is it too early to start? No, it's not too early to start, but it's not too late to start either. In fact, now is just right. I left this slide in because I really want to, this is not an Oracle product thing. I have no control over Oracle products. I didn't want any journalists to get overly excited about this and say, oh my God, Oracle's go. No. Like, this is something that we as an industry need to be doing. So why? What problems am I trying to avoid here? Some of you may remember the 32 to 64-bit transition that happened sort of in the mid-90s, and there were a lot of so there are several different pressures around why did we need to transition from 32-bit to 64-bit. One was file sizes, and so we had this thing called the Large File Summit that concluded around about 1995. We had some of these awful things around, having an L off T as well as an off T, and just all kinds of dreadful things around. People had to modify their source code in order to support 64-bit files on 32-bit systems. And we had, double LLseek. I just don't want to see us come up with LLLseek, right? Let's try and avoid that. I mean, really, we're trying to reduce the cost for the entire industry here. We're looking to impose some cost on some companies in order to avoid larger costs for the whole system. In fact, some of these problems we're still dealing with today, not so much 64-bit files, because now we've all got 64-bit CPUs, but some of us are still using 32-bit CPUs with more than 4 gigabytes of memory, which is the second bullet there. I don't want us to have config high mem on 64-bit systems. Those of you who don't work on file systems or don't work on memory management may not understand that there is a real significant cost to still carrying around all of the legacy support for these 32-bit systems with large amounts of memory. And people are still manufacturing them today. Right? The first systems that had support, yes, exactly, Keith. Your employer is still manufacturing this today. Please stop. Billions of devices are still shipping 32-bit with more than 4 gigabytes of memory. It's really sad, and it needs to stop. But let's not get there again with 128-bit. Let's transition the entire ecosystem over to 128-bit before we get to the point where we need to do that. So the obvious solution is 128-bit general purpose registers. Now, 128-bit registers are not actually a new thing, right? Intel's had them in CPUs for 15 years or something, right? Like the Pentium 2 or Pentium 3 had a 128-bit register. But they're not general purpose registers, they're special purpose registers, they're MMX registers, or they're AVX registers, or whatever acronym soup Intel's chosen to use this week. What Intel don't have is a 128-bit ALU. They don't have the ability to do arbitrary arithmetic on a 128-bit number. They treat that 128-bit register as containing 2 64-bit or 4 32-bit or whatever. Right? So we need 128-bit registers with 128-bit arithmetic in order to use them as base registers for pointers, for example. So when are we going to need this? Well, I went off and did some research, and yeah, it's probably going around about 2040 to need it for file sizes.
I wanted to add a little sop to the CPU people here. We don't need huge amounts of we don't need like multiplication of two 128-bit numbers. I mean, they're probably going to do it because you want orthogonality in your instruction set. But actually, if you want to know what needs to be fast about this, then it's some simple operations. It's shifts, addition, subtraction, comparison. These are not hard things to do. It's not like we need a 128-bit multiplier that's as fast as a 64-bit multiplier. I'm okay if that's slow. Sorry, was that a question? No, you just... I'm sorry? The comment in the room was, shift is hard. So that's file sizes. What about user address spaces? Oh, that looks like it's around about 2035 as well. Okay, right, so two things happening around about 2035. This seems like we're going to need to get it in place for 2035. And then I talked to Case Cook about this, and I was like, yeah, you know, we're going to need this in 2035. We should probably start on this in 3 to 5 years. That'll be plenty of time to get it all in place before we actually need it. He was like, no, oh my God, no. We need this right now. We are running out of bits in our pointers. We need lots more bits in our pointers. If you look at things like the Cherry project, they're already using 129 bits, in fact, in their fat pointers or authenticated pointers, capabilities, their capability pointers. But even for those of us who are not using an experimental system, like on your laptop right now, you're probably using address space layout randomization, ASLR. We use address space bits to give us more security. So we choose random places in the address space to put files and memory, and that makes it hard for attackers to find the things that would let them successfully attack our systems. And that's good, but the more bits you have, the more effective it is. And if we use larger TLB entries, and we want to use larger TLB entries for efficiency, then that reduces the effectiveness of ASLR. So if we had larger address spaces, we would get more of both of these different kinds of security. Now, another way that I skipped a step there. The second kind of, so one kind of security is ASLR. The other kind goes by a different set of acronyms depending on your CPU and you know, because we can't all share the same acronyms, of course. You know, ADI, TBI, LAM, MTE. I can't even remember what half of these acronyms stand for, but they're all basically the same thing, which is that we take some of the high bits of the pointer and we put a certain amount of information in there. And whether it's checked by hardware or by software, the more bits you have that are used to authenticate your pointer, the more effective it is. And that authentication can be various different things like, you know, just am I accessing a freed pointer? And so you look at the bits in your pointer and you compare it to the generation number of the memory you're looking at. And if they mismatch, then clearly you're referencing a freed bit of memory, which is bad, as I think we all know. So Cherry is an interesting project. I've been talking to some of the Cherry architects. I don't understand it well enough to talk in detail about Cherry, but basically they're using a lot of extra bits in order to give you security with your pointers. You make sure that you really are referencing the thing that you're supposed to be referencing, and it's supposed to make it impossible to guess a pointer. You should not be able to manufacture a pointer to something that you do not have access to. So that's really cool in and of itself, but they're not doing anything for, so they're using extra bits in the pointer and they want that, but it doesn't do anything for the address space crunch. So if we spend a lot of effort to support Cherry, we may end up having to do a whole bunch more work later on in order to do the address space crunch. So, you know, we should do the work to make sure, if we're going to do these changes, let's fix everything all at once. So, how does this look inside the kernel? And I'm kind of assuming that I'm talking to kernel programmers at this point. So on 32-bit, we have this model called ILP32, where everything is 32-bit, except that we have this get-out clause called long, which originally wasn't part of the C language, but then everyone added it, so the C-spec people added it to the language. So long is 64-bit, and that's how we do access to 64-bit files. On 64-bit, the type long is now 64 bits in size. Pointers are 64 bits in size. So this is called I32 LP64, or just LP64 for short. So what model should we have for 128-bit? Like when we're programming a 128-bit CPU, what's our C programming model? Initially, I had thought for this third option. We would leave int at 32 bits. We'd leave long at 64 bits. Pointers would now be 128 bits in size, of course. I mean, there's no point in doing this if we don't do that. And long would also be expanded along with pointers to be 128 bits in size. This seems like an obvious model, and we've used all the C types up to this point, and we're done. Some people also propose that we add long, which is 128 bits. No, that's going too far. Stop it. But Linus quite correctly pointed out that I was not really thinking straight. The assumption we have inside Linux is that long is the size of a CPU register. And if our CPU registers are 128-bit, then obviously long also has to be 128-bit, because of all kinds of stuff we do with a long, which is, we say, oh, this is a long, we will now search it for a set bit, or this is a long, we will take a CPU register and we will stick it in there. And not to mention the assumptions we have that the size of a pointer is the size of a long. So in that case, int 32, long pointer 128. Now we've got a different problem, which is that we now have no type, which is 64 bits in size. There's nothing between int and long. I don't think we're going to get any support from the C committee to add a medium. So, but I think we can probably ask the compiler people nicely and get a int 64_t. They've already added a int 128t, so that people on 64-bit systems can talk about quantities which are 128 bits in size. There is not support on 32-bit systems for 128 bits, so you're probably never going to be able to cross-compile something from 32-bit to 128-bit, but I think we're going to be okay with that. Seems like a reasonable restriction. Do we have any compiler people in the room? I asked a couple to come along, but nobody's raising their hands. So either they're scared or they had other talks to go to. So along with that, I mean, using int 64t, it's kind of messy. So I'm actually going to suggest to people that we switch to Rust types. For those of you who are not familiar with Rust, int becomes I32, which I actually like, right? It's a reminder to you, this is not an integer. This is not an abstract mathematical concept of an integer. This is a 32-bit quantity. This is going to have behavior when you get to the limits, and it's going to wrap, or it's going to fault, or it's going to something. The other thing I really like about Rust types is that they chose the same name for unsigned int that we did. Inside the kernel, we use U32 when there's something specifically 32 bits in size. Yes, I have a question.
Why doesn't it work?
Yeah.
It does. Why don't you use stdint.h?
I shouldn't laugh. I'm not laughing at the person who's asking the question. I'm laughing because this is something which has come up many times. It's so to a certain extent this question has been asked and answered by Linus, and he has said we are not doing that. We're not going to be doing stdint. I forget the details of why, but there are differences between what the C Standard Committee has decreed for stdint.h and what the rest of us do. Ted, do you happen to remember? Oh, you do? Oh, Keith remembers. Fantastic.
The difference between stdint and what the kernel does is that in stdint on a 64-bit system, a 64-bit type is a long, and in the kernel, a 64-bit value is an int. And that means that if you print a 64-bit value in the kernel, you need to use %d, and with stdint, you often have to use %ld.
Right.
Not because they're different sizes, but because
they are different types.
They're different types.
Yes, they happen to have the same size, but
yes. And this is a bug in stdint, not a bug in the kernel.
I think you got that slightly wrong. I think it's long versus long, because they happen to be the same size.
Yeah.
And the other thing is that when you print a stdint, you have to use PRI64 or whatever it is. Whereas we actually like to have code that's readable inside the kernel.
Yes.
I understand why the C committee made the decisions they did, but we were able to make better decisions because we control all of our own source code.
The other reason why, practically speaking, Linus is against using stdint is that stdint is under the control of the compiler, and on some compiler implementations, pound including stdint drags in a truly awesome number of header files, which we would prefer not to do.
Yeah. We actually have problems on, even without stdint, we actually have problems on some architectures where size t is defined as being long, and most architectures size t is long, but on some architectures size t is int, and this causes compile warnings, and therefore the compile breaks, and it's unnecessary pain. So we should probably try and we should probably, I'd like to be able to get that fixed. Again, there's no compiler people in the room, so I'm not talking to the right people, but it would be really nice if we could have, a compiler flag that says, no, I understand that int and long are the same size, but make size t a long and not an int. Anyway, discussion for another time. Yeah, so Rust actually has all of the types that we want and need, and frankly, we should just switch to them. And it's going to make people more comfortable when switching between reading Rust code and reading C code if everyone's using the same type system. And the only real difference is that the kernel uses S32 and Rust uses I32. Similarly, I64, S64 for the signed types. We should just give up on S32 and use I32. Just be the same as everybody else. I mean, who cares? Yeah, and use some places we're using long explicitly or long explicitly to mean a 64-bit type, and that's something we're going to have to change and make sure that we're using a U64 or an I64. That's just a new something that will become a bug on a 128-bit system. And while I'm ranting about in-kernel types, I wanted to say that in a whole usually when, Keith, yep.
Would you say that the kernel should just switch to using specific sized types for every variable?
Not for every variable.
Why not?
I think, well, because sometimes your variable does depend on the word length of the CPU. And for those, you should use iSize and usize.
Yeah, explicitly, one of these explicit types, not any of the core C types. No char, short, int, long, or long.
I would be in favor of doing those kinds of conversions. I would not be in favor of seeing giant patch series from random people with random email addresses saying, here's a patch that converts all of the types in this driver. I would be in favor of maintainers of code converting to it gradually over time. Yes, and so in a number of places, we use unsigned long as the type for this is a user virtual address. And I would like us to add a uaddr_t to say, and this is not an unsigned address is always unsigned, but specifically the U in this case would mean user address type. just because there's a whole bunch of things which are an unsigned long. I've mentioned a lot of them already. It probably makes a lot of sense to just use uaddr_t. One of the things that the Cherry people have impressed upon me is that there is a distinction to be made between a user address and a user pointer. So if you're in a driver and in your ioctl command, you have received a pointer from user space and you're going to write to it, that's a pointer. If you have taken a page fault and you're going to be installing a page into the page tables to say, yes, this will satisfy the page fault, that's an address. So if you're writing to it, it is a pointer. If you're just dealing with it, it's an address. And going backwards, you can't turn an address into a pointer because a pointer is authenticated. You can tell whether a pointer belongs to you or whether the underlying memory behind it has been freed and now it's you're no longer supposed to be able to access it. It's a fairly subtle distinction. It takes people a while to really get their heads around it. But it's a distinction that I would like us to start making inside the kernel, because I think it's generally a good way to be thinking about these kinds of things. Whether or not Cherry is a success in the marketplace or not, I think it's a useful thing for people to get their heads around the distinction. Any more questions about users, about in-kernel types before I move on? Okay. So we have a compatibility layer inside Linux. In general, you're allowed to run 32-bit processes on a 64-bit kernel. This is very important, right? For a long time, applications were not being built in user space under 64-bit. I still have a number of binaries on my laptop which were compiled as 32-bit. They still run perfectly on my 64-bit kernel. That should obviously continue. So we have a compat layer. We say, oh, this system call was defined with 32, it has a pointer to a structure. That structure has 32-bit types in it. So we will continue to support that. We will have conversion layers so that everything continues to work. And that's fine. But then when people were a bit smarter, they said, well, if we define these new system calls with 64-bit types in them, whether or not the application is running in 32-bit mode, then we don't need a compatibility layer for this syscall, and everything will be better. And here I am saying, well, maybe 64 bits wasn't quite wide enough. So we are going to need to actually not pretend that 64 bits is enough for a pointer, like this example, clone args. These are the arguments to the clone3 system call. So I've annotated in the comments which ones are okay and which ones are actually pointers. And they are pointers, not addresses. I went through and checked, and we do in fact store to the addresses there. So they're pointers, not addresses. So yes, we will need to say, okay, that's actually a pointer. It's not a U64. So how do we do that? And I'm suggesting that we have a new type that we expose to user space called _PTRT. And we have to put the double underscores on the front because we have to obey the C standards for symbol visibility and symbol naming and so on. So that's why there's the double underscore. And we just make that 32 bytes, 256 bits. It's more than we need. That's good. I don't know who's going to come up with something that says, well, pointers really need to be 256-bit. There are academic papers out there that use 256-bit pointers. I think Intel may have even come up with a spec for something that uses 256-bit pointers. Hey, more than we need now. Maybe not more than we'll need ever, but yeah, maybe more than we'll need ever. But that's okay. It's only memory. We've got lots of memory machines these days. Don't whine. So back to the compat layer we had for a moment. We've only the way it's currently written inside Linux, we only support one. I would be very sad if that continues to be. I want to be able to run both 32 and 64-bit applications on my 128-bit kernel. So we've got a bit of work to do there. And then further inside the kernel, we have a number of data structures which we lovingly laid out by hand, and they're just going to get completely wrecked by making pointers 128-bit, and indeed by making longs 128-bit. There's all kinds of places where we sort of intermingle various types that we know are naturally aligned, and all of a sudden they won't be naturally aligned anymore. Oh well. Struct page is going to grow to be larger than 64 bytes. So now it's going to be 2 cache lines and not 1. Oh well. There are drivers and core bits of the kernel that have code in them like hash if bits per long equals 64. Well, now they're going to have to grow a 3rd place. So I don't know if we'll bother to develop tooling to look for all the places which check, is it 64 or 32 to say, or 128 maybe. I suspect we'll probably just do that by hand. I mean, fundamentally, this is porting Linux to a new architecture. We've done it a bunch of times. We've rarely done it from, we did it once from 32 to 64-bit. It was Linus. It was an earlier time. So it was easier back then, but we can do it again. We've done it before. Yeah.
I think everybody who's lived through the 32-bit to 64-bit transition.
I'm sorry, Ben, could you tilt the mic a little bit?
Yeah, sorry. Everybody who's lived through the transition 32 to 64 and the compat layer probably thinks, like me, never again. I think we should really automate the generation of the compat layer as much as possible, especially with all of the much more advanced tooling we have these days. We can parse data structures, formats, and type information and whatnot, PA hole, you name it. I think we should really, really, really thrive to, as much as possible, automate it. Because it's broken. It's always been broken. Always had bugs and corner case. We never quite got it right. And it was so painful. So bloody painful. So I would put that, I personally, if I was in your shoes, I would put that as a requirement.
In my shoes, you say?
You're going to lead that project, aren't you?
So I'm looking for someone to lead this effort. I have a few projects on the go right now, as some of you know, because you're getting flooded with patches from me. I mean, if nobody steps up to do this, then I will. I'm actually really hoping that Arndt Bergman will step up and volunteer to do this, because I think he knows the right people. He's got the right clout to, and I mean, he's earned our trust to be able to do this kind of effort. Right? He's worked on. No, it's not that I don't like Arndt. I love Arndt. Oh, fantastic! Be
careful, he's on the chat.
Yeah, he's on the live stream, so he sees you.
What does he think? So I wanted to talk about, while we're waiting for Arndt to type, the RISC-V people have a 128-bit extension, which is sort of, really, it's a placeholder. I read through some of their documentation. It also says, well, nobody's ever done a 128-bit CPU. We really don't know what we're going to need. Here's some space for it. Maybe they have more up-to-date documentation than that, but that was the most recent thing I was able to find. And I think that's fine. Like, I'm not mocking them at all. That's several steps further than any other CPU architecture that I've been able to find. We're going to need a compiler that targets 128-bit CPUs. Again, this is something which has not happened before, and there's going to be work to do. Again, I was hoping the GCC people would be here. Yeah.
So there's a response from Arndt. I don't know if it's to your question. He types, we also mentioned having more than one combat ABI in the long talk yesterday. This may have to be a step we do first. After, we can deal with what having x86 64, ARM 64, x86 32, ARM 32, syscall calling conventions in a single kernel. We can add the more complex translation.
Yes. This is from the Loong people, the Loong Arch people. Yeah, I wasn't able to make it to that talk. I had a conflict, but I did read about it later. Yeah, so they have various compatibility days that they want to do, and absolutely that's a step in the right direction, and it's an easily decomposable project from everything else that needs to happen to get us to 128. The other thing I'm hoping to accomplish with this talk is to get people talking about it, to get CPU companies to the point where they're like, yes, this is something we are going to do. We are going to help move the computer industry in the direction of 128-bit. We understand it needs to be done sooner rather than later, and we're going to have it in real CPUs that, you know, are manufactured on like 2 nanometer or 1.3 nanometer processors in 5 years' time. You know, that would be fantastic. That's where I really need to go, because I'm signing the CPU companies up to do some work here, and
Are you sure we want to do that? You sure we want Itanium 128?
Of course I want Itanium. No, I mean, you know, the real CPUs that still exist, right? I've had mixed success in talking to CPU companies about this privately. One of them literally laughed at me, and one of them said, yes, we've had some interesting discussions about this internally, and we are very, very interested. So I'm hoping to have more responses from other CPU companies that are less laughter focused and more, we're going to turn this into a future product. I shan't name the one that laughed at me, even though, you know, they deserve it. So yeah, my conclusion: avoid the huge pain of physical address extensions and large file summer hacks by moving to 128-bit registers soon. We need to get moving on this. It isn't too late to start. We still have time to avoid it. I know it looks kind of stupid to be doing this in 2022 when we're going to need it in 2035, but people are still making 4 gigabyte 32-bit machines today, and we just need to make the pain of doing that in the 64-bit so high, because Linux doesn't support it, that nobody thinks about doing it. It's just like, oh yeah, I'll buy a 128-bit CPU. It's only 1 cent per CPU higher than the 64-bit CPU. I'll eat that cost, rather than putting millions of programmer hours into fixing all of the code. So, questions? Dave again.
Question. Have you talked to Microsoft yet?
I haven't talked to Microsoft. I believe we have a Microsoft employee in the room. But are you talking about Windows specifically, or are you talking about...
Windows.
Yeah.
Because they decided to do 64-bit differently than we did.
Oh, that's a really good point. Yeah, the Windows 64-bit model is pointers are 64-bit, longs are still 32-bit, and I forget what integer type they have. Is it long for? Yeah. No, I haven't talked to Microsoft about it at all. I assume. Well, I was about to say, actually, I have no idea. That will be a really interesting problem for them to solve. Because, I mean, we're kind of in the same situation as them, right? We have legacy code, they have legacy code. Unfortunately, they are different problems of legacy code, but yeah, they've been through it before. It's going to be painful for them. It's going to be painful for us. Again, but I mean, for them, the longer they have to fix up their problems, the better. The same as us. You know, they also did an alpha port, probably roughly around the same time we did an alpha port. Yeah, pain. It's always pain. It's just, you know, making sure the right people, reducing the amount of pain throughout the industry is, I think, where both Microsoft and we will agree. Unfortunately, that does shift the pain to the CPU companies that we don't actually have any control over. But hopefully we can move things along more expeditiously than the industry moved to 64-bit. Question from the bridge?
Yeah, I think Arndt wants to say something. I'm not sure if it's technical.
So, can you hear me?
Arndt.
Yeah. So I think we have two really hard problems here that we might want to separate. One is running the kernel itself with 128-bit pointers and longs. And then the other one is running user space with an interface, like a user space interface using 128-bit pointers. So we might want to start with keeping a 64-bit kernel, but adding the 128-bit ABI rather than doing the other part first and then adding the compat layer at the same time as trying to get anything to work at all, which is hard enough.
That's a really interesting suggestion, Arne. Thank you. I hadn't thought of that. I had simply assumed that we were going to do 128-bit kernel with 128-bit user space, and we would never support 128-bit user space on a 64-bit kernel. But you're suggesting that actually that is what we want to do, and that's a really interesting idea. Thank you.
I think Linus had this suggestion originally about Cherry and Morello, saying that we want to keep running a 64-bit kernel. We don't want to throw everything in the kernel overboard just for an experiment while we're trying to get 128-bit pointers in user space working.
I'm sorry, I don't think your mic's working. Could we get the other mic to...
So besides pointer authentication, address layout randomization, and possibly like files that are bigger than planet Earth, right? Like the power cost of 128-bit systems and also the memory cost are like significantly higher, right? Because you're basically doubling everything, right? So is that actually going to become like a viable platform?
Well,
with the expectation, like
people said that about 64-bit, right? I mean, if you go back to the mid-90s, people were saying, no, with the 64-bit pointers are too expensive. What we really need to have, and indeed, DEC implemented 32-bit personalities so that you could do you could for your on your DEC alpha, you could pretend pointers were 32-bit. You had a 32-bit personality where only the bottom 4 gigabytes of your address space was used. Because that was, I mean, if you look at the spec CPU benchmarks, there are some which do perform better if they're compiled as 32-bit executables. Nobody cares. People just don't care enough. Yeah, I'll take the bridge first.
Okay, maybe Jessica wants to comment on Cherry BSD. And then the gentleman.
Yeah, so this was just to follow up on Ard's point about doing 128-bit user space on a 64-bit kernel. When you're dealing with 128-bit integers, the problem's not too bad because you just, you just take your 64-bit pointer, shove it into a 128-bit variable, and you can get away with it. You still need to be slightly careful because void star in the kernel is no longer big enough to hold what user space is using. You have void double underscore user star that helps you a bit to automate sort of conversions for, I want this thing to now be a 128-bit pointer. But you need to be a little careful around the compatibility interface, but it's not too bad. In the context of Cherry Morello, which you said Linus was talking about, it's a lot harder because you can't just treat a 64-bit integer as a capability because it's not a valid capability, it is still just an integer. And there it gets much more invasive to try and do what we call a hybrid kernel. So it's what we did in Cherry BSD for a long time for the exact same reason that it seemed attractive of, God, there's a lot of kernel code. It sure would be nice if we didn't have to make it all work just so we could run user space. But we found that you end up with a lot of annotations all over the place to say, no, this pointer that you think is a void star is really actually a capability, not your 64-bit integer. And so in the short term, it's quick for getting something working, but in the long term, you never want to have to maintain that thing because it is such a massive diff that you have to upstream, or in our case, keep downstream and maintain indefinitely.
Thank you. Appreciate you dialing in.
Yeah, so I was going to reply to you here, actually. There is a use case that keep creeping up, and these things have existed in people's minds already 15 years ago, which is to have unified address space at large across a large amount of machines. And with the arrival of technology like CXL, for example, this is getting more and more of a reality. So, and in those contexts, this is really where you want extremely large address spaces, because you effectively want to collect the address space of potentially a very large amount of systems in one unified space. So, and I suspect that kind of use case might become more common in a world where we have 128 bits.
Like, my response to that would be just like in those systems when you have such a large address space, right, to reasonably assure that the reliability of that space is still there, right, when you access it, kind of like breaks the constraints of actually having like a reliable pointer to that space. Do you know what I mean? Like you're thinking of a machine that's so large that you can always address this by a pointer, right? But when you get to that scale, the reliability of such systems almost like mandate you that like kind of.
Yes and no, they don't necessarily need to be enormous. It also sometimes boils down to the way the hardware choose to organize pointers by sticking geographical location bits in upper bits, and you run out of upper bits actually pretty quickly because of the way you use them to identify package node CPUs, potentially other machines. And so it's not necessarily that far-fetched, and the reliability problems can be addressed if your link has enough amount of error correction and whatnot on it. And then it becomes a completely different problem anyway. But there is people who want, for example, to be able to borrow memory for neighboring machines if that machine is underutilized and the current machine is overutilized, for example. And that those sort of there's quite a lot of demand for that because memory is so expensive today in our systems. And having larger pointers make a lot of these things more realistic at scale. And again, not tomorrow, not in 5 years, but it is a case where it might be worthwhile as well.
So I think we have time maybe for one last question. Does anyone?
Okay, well, if nobody has, thank you all for coming. Thank you for not laughing.
All right, so hi everyone, I'm Liam. I'm from Oracle and I'm here to talk about the maple tree. Been doing this for a project for a few years. but just want to go over an overview if you haven't seen any of the talks before. This is a self-balancing B-tree variant. The nodes are 256 bytes or 4 cache lines. Can operate in RCU safe mode, and it supports bulk loading. Initially, it was designed to track the VMAs because the VMA changes were pretty messy with multiple data structures. The tree itself supports multiple nodes, branching factors of 10 or 16. Other node types are planned. So why use the maple tree? Well, the number one reason is it's easy to use. There's no need to write your own search function. It's fast. I was able to remove the VMA cache structure and maintain the same performance. You also use it for non-overlapping data. We don't support overlapping data, so it stores ranges internally with a size of 1 supported, so a singleton. I also support pre-allocation. Only nulls are combined into the same entry, and on the pre-allocation currently, it's assuming the worst case scenario, so you'll always have space. The raison d'etre was because it's a shift of balance between the CPUs and the memory speed has made it more beneficial to have a more cache efficient data structure. So I went through and looked at some of the most common data structures, and the number one still is the linked list in the kernel. Also doubly linked lists. It's the most widely used. It's what's considered an intrusive data structure. That is, you embed it in your own structure. I'm sure most of you know that. So when you think about searching, you're going from the previous to the next. You're pulling your whole structure into cache just to find the element you want. So there's also the RB tree, which is what the VMAs use currently in mainline. So the RB tree is also intrusive. You embed your nodes. So it kind of suffers from the same problem. As you search for something, you're blowing away your cache. That's not ideal. Yeah, it means it's also complicated to use. So a lot of people have a bit of an issue using it because you have to write your own search function. So the way that people get around this is they use the interval tree. The interval tree is based on the RB tree, but it has a search function for you. So it, again, suffers from the same problems. You're searching for something, you're destroying your cache. When people use the RB tree and the interval tree, a lot of people I spoke to about this get around iterating through it by adding a linked list to their structure as well. So you end up with multiple data structures just to have a list of things, which isn't great. What's that? Yeah, and then there's the radix tree, which is a try really in the kernel. It's pretty inefficient when it gets sparse data, which we'll see later. I'm going the wrong way again. So a little bit of an update on where I am with the tree. We settled, since 2019's talk, we settled on 256 byte nodes or 4 cache lines. Pre-allocation support was there before. It's a lot easier to use now because FS Reclaim made me use it for the VMA locking problems. So I have to pre-allocate for VMAs. 32-bit is better tested. I'm ported most of the tests to 32-bit except for my live capture tests, which I've if-def'd out. That's not upstream. That'll be the next thing I send. There's also some internal changes. What I would call a spanning write, which is a write that spans multiple entries or multiple nodes. The algorithm has been rewritten. And I also added something called a maple state write, which is just a structure to keep track of writing to the tree. Yesterday, the 11th, so when I was traveling, AKBM said that it the quote is up. It's in the Linux MM tree, and it's in Linux Next. So hopefully it gets into mainline soon. So it's pretty exciting. So there are a number of other places besides the VMA that we could use a better data structure, as to what I alluded to with the linked list comments. The PIDs, for example, right now it's optimized for, the tree is optimized for having ranges, so you're storing ranges, but we could optimize better for singletons. So there's a few differences between the two. The main one being a cursor, where the PIDs need to know where it's going to be used next, like your next PID. And for PIDs, you always want to be increasing, but because I'm planning to track the cursor outside of the tree, it can be used pretty much for any IDs, so C groups, FDs, you know, that sort of thing. So the gaps are tracked within the maple tree for the VMAs, because a lot of the time you want to search for a hole to put your data, but it doesn't have to. And so when you don't track gaps, the branching factor is actually higher, it's 16, whereas when you're trapping gaps, the internal branching factor is 10 and the leaf nodes are 16. So we could make a new node type to make this a bit more efficient. So right now the PIDs use the radix tree, but like I said earlier, when you're using the sparse data, it becomes pretty bad for storing things. The tree is dynamic node types. So basically, we decide what node would best fit the data that's in the node to reduce the number of nodes needed. So you can have leaf nodes of different types. So the idea would be to add something called a sparse node. Sparse nodes are kind of like maps, dictionaries, or associative arrays. Basically, you have a key value pair. If we do this, we can get 15 entries in each node. Undecided if they'll be sorted or not. So it would become a lot more efficient for singletons in this with this node type for leaf. So this is actually a real capture from a laptop. It was running for about 2 weeks. So the PIDs have been run around a few times. We captured 521 PIDs, and then we pumped them into the maple tree and the radix tree, and the results are pretty bad for the for the radix tree. So there's a lot of nodes. Over 100. What was it? It was like 110, 115 of the radix tree nodes have a single PID in them. So these nodes in the radix tree are 576 bytes. So that's not a very efficient use of space. I think we can do a little bit better than storing one PID. Comparing that to the maple tree, we get a lot higher density in our nodes, and this is without changing the node types. So that's still with the range node types. So it's worth noting, though, that because we're constructing this after the fact, the maple tree could either be more efficient or less, because it's a dynamic tree. The way the radix tree works, it's kind of, well, it's no good with sparse data. So another idea was dense nodes, which is basically just an array. So we can get 31 entries because we have a parent link in our nodes. But the entries, the location, the index is implied by the parent. So if a node starts at 20, then index 0 is 20, 21, etc. So we could get even more dense. If you look at the distribution of PIDs when you boot your system, what I noticed is you'll have a group of about 1 to 10 that are always there, and then you'll maybe have short-lived boot tasks. Then you'll have another grouping, and then it will be sparse data after that. Once you wrap around, you fill those in, they'll go away, that sort of thing. Yeah.
Can I take a mic?
Yeah. I helped.
So I looked into that kind of stuff 5 years ago or so. I did a prototype called it was an adaptation of re-implementation of Judy arrays in user space RCU. And for that kind of thing, so basically I have dynamic node size for each power of 2 size of node for the internal and leaf nodes, which are automatically resized based on the distribution inside. So if you want a pointer, I can show you that code, and I'd be interested to see how that would behave, because then you get perfect density for even the very sparse distributions.
Yeah, I'd like to see that. The one thing about that is every time you put a new PID in, you would have to do some work on your tree.
No, because so there's extra room. So whenever you have a node size, you can add and remove a few entries. It's when you hit a threshold, either lower or higher than a certain threshold value, and you put an hysteresis in there. So as long as you're within the hysteresis, you don't need to change the node size. As you go above, then you take the next representation that you need for that node, and then yes, you allocate, copy over, and everything. But as long as you stay within the hysteresis and you decide that, I mean that's a big data structure, very tiny configuration data structure that describes every node type and the thresholds. So, and I actually did it by hand, calculating how many nodes fit and everything. But please have a look, and I think that could do very well for at least for the PIDs.
Yeah, it'd be good to see. I do the same sort of thing. I have a lower threshold and a larger threshold, and I split or combine based on that. So it'd be interesting to look at.
Yeah, I think there's definitely some interesting things we could do. I think the right way to do this might be to have Judy style nodes as the leaf nodes, while leaving the higher level nodes as being the range nodes that we currently have.
So what's the memory footprint of the intermediate node compared to the leaf node? I mean, is it off and off, or is it mostly leaves, or what is it?
Oh, it's mostly leaves. Oh yeah. Well, assuming we're not, the radix tree is almost 50-50. It's really quite sad. But for the maple tree, I mean, you're looking at the usual kind of log decay, right? I think we had something like 16 non-leaf nodes, and the rest were leaf nodes for the example that we were playing with up there. And it would be even better, of course, if we were using better leaf nodes. We were simply using the leaf nodes we had because, I mean, that cost nothing in terms of development time. So yes. Yeah, I expect it to be even better.
And I guess the intermediate node is a trivial one where you basically just hit a single cache line whenever you go through that node, right?
It's 256 bytes, so it's 4 cache lines, but
2 cache lines?
4, sorry.
256
yeah,
bytes.
But when you traverse it for a lookup, you need to hit more than 1.
Maybe 3, because we searched the array of indices, and then we pluck the pointer out of the...
So this is where you might want to have intermediate nodes, which are more compact, because then you can do your lookup in the dense case by hitting a single cache line per level. And you speed up your entire lookups.
Maybe. We should look at your code.
Yeah,
please do. I'll give you the pointer.
How many entries you have, right? But yeah.
Yeah, but if you're sparse, you have few entries per intermediate node. And if you are so if you have few entries within a node and you have a compact representation, it fits in a cache line. If you get to a point where you have enough, then you can use, let's say, well, I mean, 1 entry per. So it's a flat array, right? So you get the index based on your part of the key, and it's also a single cache line entry lookup. So in almost, yeah, actually in no case do you need to hit more than one or maybe two cache line, but I think one is good for all the nodes.
Okay.
We have to talk more about that after
Yeah,
the presentation.
The other thing is you usually end up pulling in more than one cache line anyways because it gets prefetched.
Sorry?
You usually pull in more than one cache line anyways because of prefetch.
But then you get more traffic on your memory bus or on your lower level caches. So.
What Leah means that the CPU fetches the second cache line anyway, even if you don't access it. So you might as well access it.
So I guess first it depends on the architecture. Second, I mean, maybe it fetches the second, but I mean, if they need to hit 4.
We actually had node types that were just 2, and there was there was no performance gain to going to leaving it at 2. It was better to have 4. So prefetching is pretty aggressive, it seems. So it would be good to look at, though.
Okay, thanks.
Yeah, and just to add, you know, we are quibbling over tiny percentages compared to the absolute awful behavior we currently have with the radix tree.
There we go.
And I can say that as the radix tree maintainer, right? 147 kilobytes. Come on, quarter of a kilobyte per PID. We can do so much better than this.
It's really bad, right? I don't know what you store your ints in, but 576 bytes seems excessive.
So how many kilobytes is the code, the implementation?
I didn't look at that.
Maybe the PID would compensate for it. So
yeah, I don't know. Yeah. Another idea was to use it for the page cache. So because there's folios now, you can think of page cache as being ranges or singletons. You know, large folios being ranges, but we'd have to add search marks. Search marks are pretty. Wouldn't be too bad to add because we currently track gaps, and so we would basically replace the gap section with search marks, and we would actually get an extra bit that we don't currently have. But we'd have to check the performances as always. They may not. We might need to look into that. Should be fine though, I'm sure. So the marks basically would work the same way as the gaps. Gaps right now propagate up the tree from the leaves all the way to the root. So as you search through, you don't have to traverse the leaves, the doubly linked list or whatever you use today to find what have you based on the mark. But seeing as we have an extra one, we could potentially use it for shadow entry. And so we could use it for shadow entry trimming, and tree compaction could potentially occur. We'd probably use 3 node types for this with dense allocation ranges and sparse nodes as well. So here is an example of a large folio going into the current radix tree and what it would look like in a maple tree node. So it would be a single node in the maple tree. It's not the greatest way to represent a maple tree, but I wanted to keep the graphic pretty much the same for both. Basically, we have the pivots up top and the slots or entries down below. So to store this range 0, 1, 4, 15, and a range of 512 to 1023, the radix tree would allocate 2 nodes. The first one blown out here with 4 entries on the bottom, and the top is the root node. And the way that the root node works in the radix tree is that each one represents a particular range. In this case, the first one, 0 to 63. But then once you get to 512, we have an entry of 512, and the range, the pink there is buddy entries, and the buddy entries loop back to the first. So you end up with a kind of like this weird self-referencing node. But it's, again, a pretty large amount of space to store what it is. So I think we can also do a bit better here. Another idea was file descriptors, but there's very large systems that just allocate like hundreds of thousands or millions of files. You know, when you're thinking of cloud vendors or supercomputers, and they probably wouldn't be very happy if we started allocating copious amounts of memory every time they start something up. So that's probably not something, well, it's not something we're currently looking at. There's also the possibility of file systems with extents. There's a few things that need to be looked at there, adding 32-bit to 64. But there's not many files right now that are bigger than 16 terabytes, so it's probably not that common of a use case needing that. Yeah, so there's a bunch of other node types that would need to be looked at, but we're already looking at this for maybe speeding up what we're doing with it anyways. Yeah, because we're looking at something called compressing a node, compressing an index. So basically what you're looking at is instead of just implying the start of the range from the parent index, you would say, okay, well, we know this many, that this is the starting top bits of the index, and then you would add an offset, and that way we could compress and get an even more dense node. Kind of sounds like the Judy tree, actually. So I think it would benefit a lot of the other use cases if we were to do that as well. So that's basically all I have for this. Is there any questions or comments on that?
Over then. Yeah, just if you're looking for other potential use cases, it might be worth looking at the RegMap caches. We currently have an RB3 type. These are relatively small, and this is probably overkill, but overkilling problems to make them a lot better than they would otherwise be is kind of RegMap's thing. It's a read mostly, often sparse, with large dense clusters of values map where we store a copy of all the register data on the device.
Yeah, that sounds like a pretty good fit.
Yeah, it feels like a good fit, and if like it's probably not worth writing MapleTree for it, but if you've written it, then I might get around to looking at it. But yeah, if you're looking for other use cases, that's one to consider, I think.
Yeah, that's certainly something we could look at for sure. I often have conversations with people and they say, I don't need it, I have this thing that I use, and they start describing,
Yeah.
you know, radix tree, doubly linked list.
Yeah, no, I mean, like, we're just using RB3 because it was a thing that existed at the time. So yeah, like I say, it wouldn't be worth writing it for RegMap, but if it's there, it sounds like a good fit, I think, from what I know so far.
Yeah, in general, a lot of RB3 users can be converted to use the MapleTree. The only real exceptions are those which need to have overlapping ranges, because we are simply a value to pointer lookup. There's none of this, oh, we've got these three ranges that overlap this value. We don't support that. Those people should still use the RB3, but this should be more efficient for the ones that do in fact want value to single pointer lookups.
Yeah, so there's probably a few other places. It's great to hear that some people have uses the same sort of data sets, right?
Have you considered a user space implementation of this, or do you know of anyone that has considered user space implementation?
Well, I test in user space, so it already compiles and runs in user space, the same code. So yeah, it could very easily become a library. All right.
Anything from the chat?
Nope. Nothing from the chat. All right, well, thanks everyone.